privacy mechanisms. And 2 years later, I didn't have an idea for a title, so I just titled it Unlimited Ways to Bypass Your macOS Privacy Mechanisms. But these talks were like 3 minutes introduction and then 20 bugs one by one with exploits. It was fun, but still I was observing the very same bugs in applications that I've been tested and macOS, and I'd like to do a talk with let's call it a mission, an educational talk about how these boundaries, how those security assumptions on macOS work in general, because macOS is not a Linux, but it's sometimes treated as it was a Linux, but it's not. The boundaries are totally different. So let me quickly introduce you to the history. And there will be prepared. I know it's still 9 a.m., but be prepared. There will be like 30 slides about theory, about the boundaries, but then I promise we're gonna get through exploitation. I will show you some exploits. But in order to understand the exploits, you must understand the boundaries. So, history. As I said, chart of the history taken from Wikipedia. So, we have Linux in here and Mac OS X in here. There is a different branch, you see. So, there is a FreeBSD, which is ancestor of macOS, and NextStep was also an ancestor of macOS. That's because of Steve Jobs changed companies, etc. So in the end, we have macOS, which has a hybrid system. It has a monolithic FreeBSD kernel with a Mac microkernel. So we have a hybrid kernel with 2 different boundaries, 2 different security assumptions, 2 different security ideas. So for example, in Mac, the portion of the kernel which is responsible for processor scheduling, multitasking, virtual memory, inter-process communication, Mac traps, which is like syscalls on Mac. And then you have the BSD part, which is responsible for process management, signal handling, user and group management, syscalls, TCP IP stacks, and sockets. So Mac and BSD each maintain different security models. Mac's security model is based on ports, whereas BSD's security model operates based on process ownership. So you can see now, it's not like the same. We have 2 different assumptions in very one kernel, right? So that lead to vulnerabilities because it is not that consistent, especially to people that code the applications. And Mac OS X, the original one, had many children. So we have Mac OS, iOS, WatchOS, tvOS, visionOS, iPadOS. But the kernel at the very bottom level is almost the same. It mostly differs in kernel extensions, but there's the same blood pumped by the same heart. So please think about it as it was like the same kernel, the same assumptions. And many years ago, Apple created such a graphic. And we're going to go through it so you will better understand how all these Apple operating systems work. So the first question to wake you up, who uses any of Apple's security products, just products? Oh, so I would say like 50% of the audience. That's good. That's good. So let's start from the hardware and firmware. We have a kernel. Now we know it's a hybrid kernel with Mac and BSD layer. And in the kernel, it communicates with 2 different chips, at least with 2 different chips. The first one is Security Enclave, which is a hardware-based key manager that's absolutely isolated from the main processor and provide an extra layer of security, of course, because crucial security operations are delegated to the main, to the separate coprocessor, right? So it's even if you get a kernel exploit, there is another chip you must exploit to perform some security operations. And then you have a secure element, which is also a separate chip responsible for electronic payments, like, for example, Apple Pay. And this communicates, the kernel via crypto engine communicates with those chips to get, for example, device key, group key, Apple root certificate, etc., etc. And on the software level, we have a file system. We have OS partition. And OS partition is something that's not encrypted. It's sealed. there is a signature of the operating system. And nowadays on macOS or iOS, you don't even have access to these mounted OS partition, because what you see is a snapshot of it. It's read-only, so you are not able to modify at all the OS partition without a proper exploit. And then you have user partition, which is encrypted, and only this user partition is encrypted. And in theory, on macOS, you have applications that are not sandboxed and applications that are sandboxed. But the truth is, we all live in a hallucination. Because there is something called system integrity protection, which is a global sandbox over all of the applications that run on macOS, iOS, etc. But on macOS, even if you deliberately, in Xcode, you specify, I don't want my application to be sandboxed, that's a lie. You are still in the sandbox. We all live in a hallucination. So whenever you put an application in the sandbox, it has some consequences, like isolation. So before macOS Sonoma, when you put an application in the sandbox, it meant that your application cannot break out of the sandbox and access resources outside of the sandbox, right? That's how you are probably think that sandbox work. But from macOS Sonoma, it has been changed. Like, sandboxing an application means only that any other application, even though they are unsandboxed, should not be able to access your application. So a sandbox now work for both ways. So you cannot do some operations from the sandbox and outside of the sandbox on the application. So yeah, this is how the security model works. And the user partition, which is a separate partition, that's a good idea because, for example, if you wipe your iPhone, the OS partition gets untouched, right? So this is why it's that fast. So the basic things to understand at the beginning. macOS is absolutely not a Linux. And applications that run with the same UID should not be able to control themselves. This is really important. On macOS and on on Windows and on Linux, there's absolutely different assumption. And I will briefly, in some slide later, I will show you what are the consequences if this isolation assumption is broken. So if you code an application and you want your own application to be controlled by other apps, like for example debuggers, it must be signed with a special entitlement. So me as an application, I need to say, I want to be debugged. If I do not specify the entitlement, some other things will happen. I will show it to you later. And you may say, all right, but macOS is POSIX compliant, so there is a ptrace syscall, right? And with ptrace, we can control other processes when we are root. But that's not true. On macOS, ptrace is implemented, but it's not implemented as it is implemented on Linux. So even though there is a ptrace syscall, with the ptrace you should not be able to control other processes. If you are able to change the code execution flow with ptrace, let me know. That's probably a vulnerability. So let's now talk about macOS security and isolation mechanisms. So why the cross-process isolation is that important? Because without such an isolation, if you, for example, are able to impersonate private entitlements, which you may have an application running with a user UID, but the application has some special private entitlements. What does it mean? It means, for example, that we are able to bypass TCC, which are the whole privacy restrictions. So, for example, if you install an application on your iPhone, like Microsoft Teams or Zoom, and you want to open the camera to start recording, there will be a prompt, right? The application wants to get access to your camera. And you may click OK or don't allow, right? So on macOS, there's the very same mechanism. That's also called TCC, transparency, consent, and control. And the assumption on macOS is that even if you are a root, you should not be able to click on this prompt. Apple even detects on those prompts synthetic clicks. So if you are able to move your mouse programmatically, you should not be able to click this prompt. is that important, is that crucial. So without isolation, if you have, for example, a Microsoft Teams, and you are able to somehow control that process from another application, you may, if it would be possible, you'd be able to get its permissions, right? The permissions that user click in Teams. Okay, I allow accessing camera. So, that's problematic. And what else may happen if you impersonate private entitlements? Well, you may elevate your privileges from user to root. So that's by default. That's the system behavior. Because if an application has some private system entitlements, it may perform an inter-process communication to a process which, for example, executes a command as root. And this is absolutely fine because Apple has full control over the private entitlements. So this may happen also. And if you have the private entitlements, you may also grant you an entitlement that allow the SIP bypass. So the whole hallucination I told you some slides ago, that we all live in the sandbox, will break because you may bypass SIP. Or even no bypass. You may have an entitlement that just ignores the hallucination sandbox. What else could happen if you have the ability to break the isolation? You can trick third-party XPC services to perform user-to-root LP, or inject to third-party apps to get the TCC permissions, like I said. So it's kind of complicated, right? But the good thing is that Apple made a white paper called Apple Platform Security White Paper. You can download it under the following link. But unfortunately, not everything is very good documented. It's on general level, the Apple Platform Security White Paper is really great. But if you want to dig to the details, because you want to, do some vulnerability research or something like that, you need to perform some reverse engineering. So let's now talk about the system integrity protection, the great hallucination sandbox. It must be enforced on a very low level because we want even system applications to be in the global sandbox. So it's enforced on the kernel level, and it's based on sandbox kernel extension. And it will restrict access, the sandbox, to many directories on macOS. This is the thing that's responsible for denying debugger when you want to debug some Apple-signed processes. And system integrity protection is also known as rootless, because even if you are root, you should not be able to do the above-mentioned operations. That is that important. And last thing, are there any macOS developers in here? Okay, not so many. So I just tell you, for regular macOS users, if you sometimes face a problem and you Google it and you find maybe an answer in Stack Overflow, and the most voted answer will be, well, just disable SIP and everything will be fine and your problem will be gone. Please do not do it. Without SIP, everything on macOS is possible. Like, there is no global hallucination sandbox. And your application or a malware will be able to do all the things I told you before. So they will be able to elevate from user to root. The whole TCC, the whole privacy framework is turned off when SIP is turned off. So please do not do it. And I've seen such a high-voted answer on Stack Overflow too many times. Because yes, it solves the problem, right? If something on a security level doesn't work on macOS, if you kill the global security mechanism, everything will work, right? So yeah, that works, but please do not do it. How can you see if system integrity protection is turned on? Just with CSR rootless status. So if you manage an organization with macOS stations, please do it globally and check if there is nobody who changed SIP to be turned off. OK, so let's do an experiment with the isolation. Let's inject, for example, to LogDaemon with Apple's own debugger, not our own, just regular Apple's own debugger that's called LLDB. As you can see at the screenshot, we are root, We just call LLDB with the PID of logd. And let's take a look what happened in the console. The debug server wanted to get task for PID for the PID of logdaemon. There are some logs, and in the end, we can see that attachment has been failed. And what is the task for PID? PID is a thing from the FreeBSD kernel layer, but what is a task? Task is like a process, but in the part of the Mach microkernel. So you can see, even if we want to control a process, there will be change of the worlds, right? We're changing from what we know from POSIX, PIDs, to tasks. And while we have a task part, we can fully control the process. We can mess with its memory, etc., etc. So yeah, by the end, it failed. So why did it fail? Because debugging a process, which gives us the clear way to control the process, requires task port of the debuggy. And as I've just said, it involves using the task for PID function. And task for PID is allowed only under some critical circumstances. And you have to know also that the task for PID requests are controlled by taskgate daemon and MFI, which stands for Apple Mobile File Integrity Daemon. So when SIP is enabled by default, and you can take a picture of it because that's, if you want to do some macOS security research, this slide will help you a lot. I wish I knew it before I started my research like 7 years ago on macOS. So the task port retrieval is not possible when the target app is a platform binary or has a hardened runtime. And regarding hardened runtime, I elaborate on it later. But generally, if you want to debug an Apple-signed process, that should not be possible. If the debuggee, so the process we want to debug, holds a public getTaskAllow entitlement, the injection is possible even by the same user, so no root is required. And this is the situation when we have an Xcode and we said, yes, I'm still in the process of development my application, and I want this particular entitlement to be put into the application because I want to debug my own application, right? But that's also complicated. It sometimes exists on production, so if you ever will be pen testing any macOS apps, make sure that this entitlement is not present. If the debuggee doesn't have hardened runtime and was signed without the getTaskAllow entitlement, the injection is possible, but you need a root. And the injection is always possible when debugger app holds a private system task port entitlement. And this is just for your information. Even Apple-owned debugger, the public version, does not have such an entitlement. So, yeah, unfortunately. If you ever find such a process that, or such a debugger that may have the system task port, the private entitlement, it means that probably there is a malware or there is a backdoor placed by Apple, because no debugger, no public debugger have such an entitlement. But can we just impersonate some private entitlements? Let's see. We have a Hello World application. Those are the entitlements. That's a private TCC manager entitlement. As you can see, the com Apple private, which means it's private. And with code sign, we see that the hello world is not signed at all. And in that line, we just sign it with the entitlements. But if you want to spawn the application, the hello world application will see that it will be immediately killed by the operating system. And you will see that's because MFI told us restricted entitlements not validated, bailing out. So unfortunately, that happens when you have SIP enabled and you want to impersonate any of those private entitlements. When SIP is disabled, that will work. That will work. And there's a fun fact. Back in 2020, in Big Sur beta, I spotted some Apple binaries with getTaskAllow set to true. So I was able to get the task port of those Apple's own executables and impersonate their private TCC permissions. So Apple paid for a bounty for that, and I found like 5 or 6 binaries having that. And you can see the proof, because with sudo in LLDB, I was able to get access to the process. So yes, because Apple knows that the user root boundary is not that important on macOS, because when you have zip, root is not really a root as you know it from Linux. Apple pays for such boundaries. Apple pays for such vulnerabilities, because yes, there's another boundary with it. Great. So if we want to inject our code to third-party apps, because we'll be slowly getting to the password managers, we'll be looking for apps with get-task-allow, those applications that deliberately say, I want to be debugged, or applications without hardened runtime. But what is the hardened runtime? The hardened runtime, along with the system integrity protection, protects the runtime integrity of your software by preventing certain classes of exploits like code injection, dynamically linked libraries, hijacking, and process memory space tampering. That's a copy-paste definition from Apple. But just for your information, too long didn't read, blocks code injection. Hardened runtime is for blocking code injections. And nowadays, all software from the internet must be notarized. And notarization is a really broad mechanism, because Apple requires you, if you want to put your application in the internet, that you must send your application to Apple servers. They will check it against malware. They will check it against if it has the get-task-allow entitlement, because as we just said, we don't want any other application in production to control our application. And it will also see if there is the hardened runtime turned on. So theoretically, all the password managers, because they are not delivered with the system, are done from the internet, should be notarized, right? And there is even a prompt in Apple documentation that to upload a macOS app to be notarized, you must enable the hardened runtime capability. So in theory, everything should be fine. Every password manager should be correctly isolated from the rest of your applications. And how the hardened runtime is enforced? It's enforced by setting a code signing attribute, which is CS runtime. So you apply the hardened runtime during the code signature process. And as the XNU, the kernel is open sourced, you can even read it, exactly how it was coded. If you're interested in macOS security research, I will really encourage you to read the sources. Unfortunately, not everything is in there, because macOS relies heavily on sandbox extensions. And because of the license, sandbox extensions do not have to be open source, so Apple, of course, didn't open source them. Great, so how can we see that hardened runtime is turned on? We can just use the code sign tool to do this. So we just use code sign -d-v with, for example, GarageBand, and you will see that, okay, there is a flag called runtime, so that's hardened runtime. But is the hardened runtime the holy grail of giving us the isolation? No. There are runtime exceptions. So even though you have a hardened runtime applied on an application, there is plenty of different exceptions you may put on the application. So, like for example, JIT compiled code entitlement, you may allow unsigned executable memory entitlement. But from our perspective, if you want to just inject our code to the third-party applications, we are interested in those two. So allow DILT environment variables entitlement. So who of you knows the LD preload environment variable from Linux? OK, so not everybody, so I will quickly explain it. LD preload is an environment variable, and you specify a dynamic library that will be loaded when the application is launched. So with this one, you should be able to make an application load a dylib, dynamic library. But normally, if the hardened runtime is turned on, macOS will deny loading a library that has been signed with a different developer certificate. So we also will be needing this one, disable library validation entitlement. If it's set, macOS will happily load the dynamic library to the process which is hardened. So how can we see it? Also with code sign. So we -d -- entitlements, and for example in Firefox you will see disable library validation turned on Firefox. I reported it to Firefox in 2020 or something. Well, generally, macOS browsers are not well known for proper isolation. So Firefox developers told me they must enable this thing because there are Flash plugins. And I said, it's 25 or like, in what year we live? But yeah, that was the explanation of them why the entitlement is set to true. So just to sum up this part, and I promise you we're gonna get now to the exploitation. I know there's a lot of theory, but I told you that's a talk with a mission, an educational mission, because I wish I saw such a talk 6 years ago. That is really important to understand, and you cannot like freely read it in Apple's documentation. So those all circumstances that must happen to control other applications are really important to understand on this part. But however, just to sum it up, we'll be interested in password managers that have get task allow, or are without hardened runtime, or are with hardened runtime but have the useful runtime exceptions, and have some custom debugging features that don't depend on get task allow. And here, wink, wink to Electron. So if you thought that Electron as a framework is bad, you have one more argument to that list of problems with Electron. And just for your information, all those techniques that we'll be using against password managers can be used for exploiting any other applications. Like you may play bug bounty programs using this knowledge. Like there is plenty of applications, of really well-known applications like antiviruses that also have problems with those things I've just told you about. So the research is absolutely not complete. It's not like it's fully have been exploited and there is no thing like that. It's everywhere. So I just put password managers in here to attract the presentation, to make it more sexy, because we all know we all want to hear about attacking security products. But as I said, that's a talk with a mission, so that can be used against any other software on macOS you have. So let's spawn finally the popular password managers. And we're gonna start from a MacPass, which is a native macOS KeePass client written in Objective-C, so purely native application. It's available under the following GitHub website. And it has like 6.7K stars, 450 forks on GitHub, pretty known password manager. I personally use it. And when we use code sign on it, we'll see that, OK, it has hardened runtime turned on. That's good. But we have disabled library validation and password manager. And maybe that's it, right? Maybe we can just change one of its dynamic libraries, and maybe that's win. Maybe we have successfully exploited it. But no. There is another mechanism I didn't tell you about, but that's the last mechanism I'm going to talk during this presentation. I promised it to you. So with macOS Sonoma, there is something called app protection. So I told you at the beginning about the sandbox. So if you put your application in the sandbox, the additional sandbox, your files of your application will be protected as well after first launch. So only a process that is signed with the same developer ID will be able to modify your own application. And this is because, for example, you want to code an updater, right? An updater must change files of the application, and it's signed with the same developer ID, so Apple said, OK, that's fine. But why, in general, MacPass disabled library validation? Because it allows loading custom plugins. For example, you want to unlock your password manager with your Face ID or Touch ID. So there must be a plugin functionality that allows implementing new functionalities in the Mac path. And plugins are stored in library application support Mac path, so they are not protected. And this is on purpose. Think of it as on Windows, for example, you have app data. It's not the application container. It's just a directory that the application may use to get some information or to exchange it with other applications, etc., etc. So this is on purpose not protected. This is a feature, not a bug, feature. So we can abuse that feature to create a malicious plugin that can drain all the entries once user unlocks the vault. Let me show it to you. So we are in the temporary directory. We now verify if the hardened runtime is turned on. It is. Let's take the Mac passes a bundle identifier, and using defaults, we can read its defaults. There is the last database path, so we know exactly where the entries are stored. And now enable the plugin loading functionality, which is load incompatible plugins to true or 1. Great. Now let's copy the plugin to the directory I just told you about. And now just open MacPass. MacPass has been opened. And now user unlocks the vault, and then you'll see 2 files created in the temporary directory. So you will see all the credentials stored in here. And also the master password will, of course, contain master password. Great. The exploit was pretty easy. I just created a dynamic library that, after it's loaded, it immediately calls this constructor, which exchanges an implementation of a function that unlocks the password manager, which in the end just unlocks just gets the password and calls the original function, so user will not even spot that something wrong happened in the meanwhile. All right, so a question to the audience. Who thinks that this was a bug or vulnerability? Okay, I would say like 30% of the audience. So you can see it's not really easy to determine if it is a bug or it is a feature. Certainly, there should be an isolation I told you about during the first part of the presentation. But you will see that things are not that easy on macOS. So let's take a look at Bitwarden, which is an open source password manager with a premium plan. It's written in Electron and is distributed via Mac App Store. So the first thing we do on macOS when we audit an application, let's see the code signature of it. Flags none, no hardened runtime in newest version of Bitwarden. But didn't I just tell you that all applications downloaded from the internet must have the hardened runtime? I told you about the notarization, the enforcement, Apple anti-malware stuff, etc. And here we have a password manager with hardened runtime turned off. How did it happen? Yes, because I told you that applications that are directly downloaded from the internet. But Bitwarden is distributed via Mac App Store, which is not like you download an application by your browser, by, I don't know, an attachment from Microsoft Teams or something like that. And the Mac App Store does not enforce the notarization because Apple say, yes, but we have a different anti-malware mechanism in Mac App Store, so we don't need to audit the applications in Mac App Store just like we do if a developer wants to distribute it on their website. Interesting, right? And we can simply inject a dynamic library to Bitwarden because the runtime is absolutely not protected. There is no isolation between the operating system and Bitwarden. So does it mean that software downloaded directly from your browser is more secure than this downloaded from the Mac App Store. Such an irony, right? So maybe that's a mistake by Apple. Maybe it's a vulnerability in Mac App Store. Maybe I should have reported it to Apple. But let's take a look at the documentation. We are in embedding a helper tool in a sandbox app documentation. Add the hardened runtime capability, which is not necessary for App Store apps, but is best practice for new code. Not necessary for apps distributed via App Store. So how can we exploit Bitwarden? Simply. Just start the logs and just, let me come back in here. We just use the open function with env to insert the dynamic library. Then we have Bitwarden. User provides their password. And I just put a simple keylogger that logs it, nothing more. So we have the password to unlock the vault, and we can steal files from Bitwarden and just unlock it on our own, on our computers. The keylogger is pretty straightforward. Like everything I do is mostly on my GitHub or gists on GitHub. So you can find me on GitHub and just download it. It's a really simple keylogger. So the next question to the audience: was this a feature or a bug? So who is for a feature? Okay. And who thinks this is a bug? Well, now most of you think that it's a bug, but is it? There is a clear, information in Apple's documentation that it's not necessary to do it in macOS App Store. So let's take a look at NordPass, which is also written in Electron, but is directly downloaded from the internet. So by directly downloaded from the internet, I mean you used your browser to do it, not Mac App Store. And here, critical Electron fuses are turned on, what allows code injection. If you want to know more about the Electron fuses, last year I had a talk on DEF CON where I automated the whole process and released an open source tool that just auto-exploits Electron applications and gets all the TCC permissions, but it's all open source. So if you'd like to dig more in it, just watch the talk. But generally, use such a command to see if there is Electron fuse, a critical Electron fuse enabled in an Electron app. And as you can see, there is enable node CLI inspect arguments, which is enabled for NordPass. But hello, Electron applications are like applications with embedded browser, right? And browsers provide functionality that you can, for example, open dev console, right? You can place your JavaScript script in it, execute it, right? This is how browsers should work, right? So if Electron is an application with an embedded browser, is it a bug or a feature? You will determine in a moment. So let's exploit it. I will be using my tool that I just told you about. So before I do so, I just export to nvar, so the exploitation will be easier. And now my electronizer, my tool, that will open the NordPass master password stealer. There is the WebSocket server started by the Electron application. There are dev tools, but just via WebSockets. User authenticates. We have all the items. And now let's see if the master password has been dumped. Yes, we have the master password. So again, we may perform the same technique we did before with Bitwarden. Just use this key to decrypt the vault. And the exploit is purely a JavaScript file, because we just opened DevTools and executed JavaScript code. So again, a question to the audience. Who thinks this is a vulnerability? No. Always 50-50. You can see that's not that easy. I encourage you to discuss it after the talk if this is a bug or this is a feature. All right, and the last password manager, sorry, the one before the last one, the KeePassXC, which is downloaded from the internet, completely open source. It's native because it is written in Qt, and it's very well documented. If there are any developers of KeePassXC on the audience, big kudos from me. That's a really great password manager. But because I wanted to show you different perspectives on that problem, now we're gonna talk about a browser plugin. So there is a plugin that you may install in your browser. And under the hood, there is some asymmetric crypto. It is all documented, but I will not bore it with you. Just you may just understand that we know the connection name and the private key, nothing more, to impersonate such a connection. And I told you that macOS browsers are not really well known for proper implementing isolation. So we can simply get the local storage logs, the private key from it, and spoof the connection. Just open browser files. Browsers on macOS except Safari are not sandboxed. So you can access their containers, enter some local storage, and just get the private key and the connection name. That's that easy. So let me show you the demo. We have the KeePassXC. This is the whole code. Somebody created even a Python package for it to communicate with the main KeePassXC application. Thank you, the developer. And this is the command I just used to get the connection name and private key from the browser files. It's not sandboxed, but the browser is not sandboxed. So it's a feature. And yeah, we were able to get the entries from the password manager. This is the whole exploit, really easy. Who thinks that it's a feature? This thing. Who thinks this is a bug? Okay, 50-50 again. There is nothing wrong with KeePassXC, right? They implemented everything correctly. There is a asymmetric crypto communication. Everything is verified. There is no vulnerability like we can impersonate something. We have the private key, so that's the browser problem, how it stores it, right? Not that easy. And the last password manager is ProtonPass, which is a plugin-only password manager. There is no standalone macOS app. It lives only in the browser. So all encryption, decryption happens in the browser JavaScript runtime. And here we can just use Selenium framework to automate browser and get all the entries that are decrypted in the runtime. Nothing complicated. Again, NordPass. It was their decision to make it as a plugin, right? The exploitation is finished. It was that fast. It was their decision to do it like that. But again, this is probably not a problem with the NordPass itself. That's maybe you can say that's a wrong architecture decision to make it as not a standalone application, but a browser plugin. But again, there is a problem with browser isolation, not with the ProtonPass itself. So yeah, I encourage you to open a discussion after my talk. But here we need to sum everything up because we are out of time. So at the very beginning, I told you about the basic macOS security assumptions. macOS is not a Linux. Security by isolating applications processes are really important on macOS. You now know it. So if there is no isolation, you can impersonate privacy entitlements. You can elevate your user to root. There are many possibilities if the isolation is not turned on. So we went through some different password managers written in all different technologies or downloaded from the different context. I still don't know which are features, which are vulnerabilities. I leave it to you to discuss. But I told you at the beginning that I don't want to leave you without recommendations. So some crucial points. Enable hardened runtime, review hardened runtime exceptions, Enable sandboxing, because now it will protect applications from the outside to not get to your app container. Notarize your applications, not only installers. If use Electron, disable problematic fuses, and pen test your apps. And as I told you, I'm a creator of an iOS application security engineer course for pen testers and developers. So I created a 10% discount for Security community. So if anybody's interested, feel free to use this discount. And that's it for today. Thank you very much for your attention.
Thank you very much, Wojciech. Yeah, that was a lot of interesting information in there. I was actually very impressed. Because I read the submission as it's like all the password manager things, but then you got the whole lecture about the actual security.
Yeah. The password managers was only a trick to listen, just to trick you to listen to this presentation, because I needed to give you something, sexy password managers, but I wanted to give such an informational talk about all the boundaries. The public must finally understand the problems, because my first presentation was about pwning antiviruses, and we spotted isolation problems in like 80% of all antiviruses on macOS, and we were able to elevate our privileges from user to root just by breaking the isolation. So please spread the knowledge, play bug bounty programs, earn money on it. The research is not over.
Well, we were absolutely very, very happy to see all that content in there. Thank you very much. Again, this is time for break, so say thank you again to Wojciech. And then we have a 30-minute break, so go grab a coffee and whatever you can find to eat. And we'll be back here at 11.
Okay, now we have stuff happening. If anyone can invent actually an HDMI interface that works with everyone's laptop, I'm willing to invest in the company. Even the conference are willing to invest in the company. But without further ado, welcome on stage, Alexander.
Thank you very much. All right, so I figure I'm going to start with a demo. And what you see here is a fully patched hypervisor called Hyper-V. I guess some of you are using that maybe in your production. If you're using Azure, then you're using that because that's how you run a virtual machine in Azure and so on. And we have one virtual machine here. It's called Server 1. And in this prompt here, we have the hypervisor. So you can run, get VM, for example, and you can see all your virtual machines. And if you run get VM, and then you get like the ID and the name, not select. There we go. Okay, so that's the VM ID of this virtual machine, right? So in Hyper-V, there is this concept of PowerShell Direct. And PowerShell Direct is like the modern way to manage your virtual machines. So you can, from the hypervisor host, run PowerShell commands inside the virtual machine. And it's pretty cool because it doesn't require networking, and there's a lot of backup solutions and so on that rely on it. So if we do invoke command and we say VMID, and we specify the VMID we just copied, and then we say script block, and we say host name could be the command that we want to run. And then we specify the credentials, because this is going to run in user space inside the virtual machine, so we need credentials to do that. We run the command, and we see that we get server 1 back. All right, so this is good and all, and this is something that is a way to manage your virtual machines. So imagine now that this virtual machine got compromised. A threat actor runs this script called exploit PS1, which starts a listener. And the admin on the hypervisor host doesn't know that it happened, of course. So as part of their daily job, they just run this exact same command that we just run. We expect the output server 1, right? We run it. It takes some time to complete. And after a while, we see that something bad happened, and we got this weird exception. And after a while here, we see that we got a shell. So now we're actually executing commands from within the virtual machine on the hypervisor host. And we can see that we are now on Hyper-V01. And of course, we can pop the mandatory calculator, and we get our calc on the hypervisor host. All right, so to understand how that worked, we need to start from the beginning of all of this. And we're going to start with this bookcase called Billy. In code, that is a class, bookcase, and the property name is Billy, and the property price is something, and so on. And you have this object-oriented concepts in programming, right? You can create a new object of that class, and then you can execute the methods, and it's going to take the members of the current state of the object and so on. Here we have a serialized Billy. He's much easier to transport than the object that you have in the store. And if you talk about this in code, then you have just a serialize function, and then you can write it to file, and you can do whatever with that data that you're going to get out. It can be stored in a database, it can be sent over the network, and that kind of thing, right? In this case, it's transported with some kind of truck. On the other side, when it's received, we have the deserialization of Billy, and code-wise, you read in the bytes or whatever text there is, you deserialize it, and you get your object back, and there you have Billy. So what we talked, what we explained now is the very basic concept of serialization. It's something that a lot of programs is using, and it's it's a very fundamental concept of software design. So what could possibly go wrong here? So what if this delivery guy is evil and changes out the delivery and delivers this instead? If there's no input validation or something, then we can end up with something like this. But of course, that wouldn't work because this person doesn't have a cow at home. So this would actually throw an exception because you can't just inject classes when you exploit a deserialization. You need to abuse the classes that are already there. So we call those things gadgets. And in this example, maybe they have a dog, maybe that will work, and that has some features that can eventually do whatever we want to do. In a programming sense, we would start looking for specific classes, like Orange Sai talked about it a bit yesterday, right? He was able to read in the user share and then find useful stuff where we're able to read stuff, right? It's kind of the same thing here, but we want to find things that we can instantiate, and hopefully it's going to trigger some kind of function in the backend, and we're going to be able to get an impact. So basically, the impact is going to depend on what specific gadgets the victim have on their system. So the impact is going to vary. Okay. I started doing this research back in 2018. And I also have a job, so I haven't been doing this full time since then. This is more of a hobby kind of thing. But at that time, there was two really interesting papers on this, and it was deserialization in Java, and then deserialization in .NET. And after that, there's deserialization in most languages, but not in PowerShell. So that's what we're going to look at today. How can you exploit a deserialization vulnerability in PowerShell? And what kind of impact could that have? And as you saw in the demo, the impact can be quite severe in some cases. So if we summarize what we learned so far, developers are using deserialization all the time because they need to read and restore and so on objects. And the vulnerability itself, that's when you deserialize untrusted data. The impact of the vulnerability is going to depend on whatever gadgets you have. All right, so what is CLI XML? CLI XML is a very common serialization format in PowerShell. Imagine that you have this string, you serialize it, it's going to be stored in this XML format. It has support for these primitive types, for example. So if you have a Boolean, it's going to be this B tag, and you're going to have integer tags and that kind of thing. It also has support for complex objects. So in this case here, you see the very basic template for it, but it can be lists, and it can be stacks, and there's a bunch of different data structures that it supports. If we take this class system drawing point as an example, we see that it inherits from value type, it inherits from object, and that's within that TN section that you see there. You also see the definition of the properties. It has this one property called isEmpty, and it's a Boolean, and it's set to false. So when this is read back, then that's going to be the value of the object that is serialized, right? So one very important concept here is that we have something called property bags. So if you take, for example, a Boolean, you serialize it to this B false B, and you deserialize it again, then you're going to get an actual Boolean. It makes sense, right? What if we serialize this system drawing point, and then we deserialize it? Then we're not going to get the actual system drawing point class back. We're going to get another class, which is called deserialized system drawing point, and that is something called a property bag. You can think of it as a dict in Python or something like that. So it's pretty much just this worthless dictionary which just has the properties, but we don't really have any of the functions in the original class, because it's not an object of the original class. It's something else. And of course, this is going to be important for us, right? Because like we talked about before, we want to find that class that we can abuse, right? And if we cannot use the original functions and so on in that class, then yeah, it's no good for us as threat actors. So when you've done that serialization, the direct way to do it in PowerShell is just use this import CLI XML. Maybe you used it once or twice. You can also use the PS serializer class directly. That's actually what's going to happen if you run import CLI under the hood. So it's exactly the same thing, pretty much. And if we follow the code, because PowerShell is actually open source nowadays, and Windows PowerShell isn't, but PowerShell Core is. But I guess that they want to keep this serialization compatible between the two. So I guess we can guess that they are fairly similar when it comes to this. So basically, if we follow the flow, we see that it ends up in this read object. And if we take how does it deserialize the primitive types, for example, we see that it goes all the way into this internal serializer, which is called the serialize on. And in the case when it's a known primitive type, it's going to use a table and find the correct function for doing the deserialization. So in the case of a Boolean, then it's going to call this deserialized Boolean, and it's going to use the XML convert, blah, 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 to convert it to a Boolean. So that's the known primitive types. If we just start looking at the known primitive types, is there anything bad we can do? And I realized pretty quickly that script block is a known primitive type. That could be an interesting class, right? But unfortunately, it's by design deserialized to a string. And there's a lot of people asking on GitHub, can you please rehydrate my script blocks? And they say, nope, we've done enough pen tests to know that that's not a good idea. So at least they've been thinking about this, right? So that's good. And if we jump ahead a bit, so keep in mind, like I said, I started this around 2018. And I work as a forensic investigator at TrueSec, and we did a lot of investigations when this thing came around. It was quite a few companies that suffered from proxy shell, you might remember. And one of the exploits, it was several exploits, right, and variants of that original exploit, which, by the way, Orange Desai, talked to him, he's awesome. He was the one who initially discovered it. He's here. But the other variant, proxy not shell, it used Orange size SSRF as the first step, but then it changed this other part to get execution in the PowerShell backend. And when I investigated this, I realized that, oh, this is CLI XML in the actual exploit. So what is this? So I started digging into the actual exploit, and it seems that there is this interesting concept of user-defined types in PowerShell deserialization. And Exchange defines one of those. So it has its custom serialization type converter. And if you look in the source code there, it's basically just wrapping binary formatter. And binary formatter is something that in JSON, the 13th JSON blah, blah, blah attacks, the paper, they figured that that is exploitable. So it's a known vulnerable function to deserialization. And the way that they abused that was that they specified the target type for the deserialization, and they specified the type as XAML reader, which is what they then define also as the final payload. So it's going to eventually create that XAML type, and it's going to have this string as an argument to the function. So basically, in the end, this is what's going to happen. So it's going to call that convert to, and they are able to control the target type, and they are able to control the argument sent to the function. And that leads to code execution. And this is really, really cool. But the thing is, this only works in PowerShell, in Exchange PowerShell. Because this is a vulnerability in Microsoft Exchange serialization type converter, right? So this doesn't really work for what we're after, right? Because we want to exploit PowerShell in general. We don't only want to own the Exchange servers. So this is a really, really cool exploit. I recommend that you read the write-up from Zero Day Initiative on it. But we're going to take some learnings from here and see that user-defined types are dangerous. And we're going to see what user-defined types are available by default in PowerShell. So I looked at my newly installed Windows 10, and it seems that user-defined is a kind of a bad name for this, because there's quite a few of them that ships with PowerShell by default. And if you look at the server, then you see maybe you have a SQL server, then that also comes with PowerShell modules, which also defines user-defined types. So eventually you're going to have quite a few of these types on your system. And on top of that, there's also hard-coded a hard-coded type converter, which is like the default type converter. And I think this is made to like support PowerShell remoting and some things like that. So there's actually additional types that are just built in to be rehydrated as well. So if we look at one of these like default types, we have PS breakpoint. So in this case, we have a command breakpoint, and we serialize it. And we see that within the serialized breakpoint, we have an attribute called action, which is a script block. And that is naturally deserialized to a string, right? Because it's dangerous otherwise, right? No? OK. So if it's in a breakpoint, then it's actually deserialized as a proper breakpoint. So that's interesting. So how did that happen? It seems that this custom function for the serialized breakpoint actually calls explicitly rehydrate script block. And that runs a script block create. So you're going to get the script block back. And naturally, we ask ourselves, what did the Microsoft developers mean when they said that there's too many places where there's automatic code execution? Well, it seems that PowerShell has this concept of delay bind parameters. And if you, for example, do what we're doing here, so we have like a pipeline stream, and we do for each object, and then we specify our deserialize.action there. That's going to execute code. That's going to execute the script block. But thing is, these are everywhere. So if we do a select object, that's going to execute. If we rename a file with that name, that's going to execute. If we like pretty much like wherever we put it in the pipeline, it's going to execute. So it's a pretty interesting like gadget. It's also kind of worthless, right? Because you know how often does someone use .action and put it as a parameter? So it's not that useful, but at least like this is our first step into this, right? We can sort of show that you can't just deserialize CLI.XML and trust the data, because it could end up with code execution if you use the code in like a completely legitimate, but you're just unlucky way. So let's continue and look into the other gadgets that, or like classes that we have available. So one interesting type is the sim instances, because those are also rehydrated. And let's look at Win32 ping status. That defines something called a type PS1 XML. And that is a way to like dynamically enrich your types in PowerShell. So often PowerShell modules comes with a types PS1. And what this one says is that take like the object and then enrich it with this IPv4 address property. And what it's doing is that it's taking this address and then it uses the getHostEntry call to enrich that and print it in a fancy way. And then there's this format file, which is kind of the same as types, but it's for the outputting of the object. And it says that we're going to print IPv4 address by default. So I don't know if you noticed, but in PowerShell, when you, for example, querying a reg key, then it's kind of beautifully printed, and it's not like default, right? That's because it has a types file to say what's going to be printed and not. But what happened then, because like that getHost function, that is going to make a DNS request to whatever domain name we provide. So this could be a gadget to make an arbitrary DNS request, right? So if we change the address field and then we import this, we observe that PowerShell is making a DNS request. So that's not really that big security impact, right? But it could be useful if we're looking for vulnerabilities. We could find that something has deserialized my payload. So it could be useful in that sense, like Java has similar ones where you can do a DNS request and so on. But I think it's more important because we are kind of learning now, right? How do we make these kind of gadgets possible? So what we need is that the victim, of course, needs to deserialize the CLI.XML, and then we need to have a class that's going to rehydrate, and we need some kind of useful property, and it needs to be printed by default. And it actually seems like there isn't that much that rehydrates, but then again, like quite a lot rehydrates, right? We have all the known primitive types. We have all those types in the default deserializing type converter. And we have sim instances, and then we have whatever user-defined types that this specific system has. So let's continue our path into looking into what else do we have. We have the SMB share PowerShell module. It defines this preset ACL path, and it does like a get path to whatever value that we as threat actors can control, right? Because in a deserialization context, we control all these attributes. So what if we set it to something like this? Then the get ACL is going to authenticate to evil server, and we can capture the net NTLM v2 hash, right? So we try importing that and see if we can steal the hashes of whoever deserializes our payload, but it doesn't work. So why doesn't it work? Well, there's a difference in PowerShell between available types and loaded types. And it seems that when you use a PowerShell module cmdlet, then it's going to implicitly load it. So it's going to feel like they are always available, but technically they're not always available until you've used them. Or you explicitly import them with import module. So that sort of limits, but I mean, as soon as we do get SMB share and then we do it, then it works. But there's also another problem, which is that this is a kind of a weird name of a variable. So this is not printed by default. It's not in the format file. So to actually make this work, we need to do these three things. We need to first import that actual module, then, or like the victim needs to do this. Otherwise, they're not vulnerable to this specific gadget, right? So they need to somehow import the module and make it available. Then they need to deserialize the untrusted data. And then they just need to like access all the objects. Because as soon as you access the property, then this is going to trigger. So when you do that, you see on your backend side that, yeah, now we captured the hash of this user. And by the way, that happens quite a lot, right? So if you do like a select star, if you convert it to JSON, there's a lot of situations where you access all these properties. But still, like, we need a better gadget than that, right? So let's look into the registry key class. In this case, it has a get item property, and it takes the PS path as the argument to that cmdlet. We can control that value, of course, because we are deserializing this object. We can construct it in any way we want. And the funny thing here is that this is loaded and made available by default. It is printed by default. So all the victim has to do is import our CLI.XML, and boom, we have their hash. So that's kind of nice. If we look beyond what I have on my system right now, we need to start thinking about PowerShell Gallery and the entire like ecosystem of modules in PowerShell. And we have one example, which is PS Framework. It has like 6 million downloads. It's developed by someone working at Microsoft. It is used by 4 official Microsoft modules. It is also used by some incident response tools and other quite well-used tools. So you can imagine if you start enumerating all the like dependencies and dependencies and dependencies of this, there's quite a few people that have this stuff on their machine, right? Guess what that modules type like thingy look like? It's a wrapper just like Exchange on the binary formatter. So in other words, on all those machines, we can execute code when they deserialize CLI.XML. And I illustrate that this way. So of course, PS Framework is definitely the only gadget out of these like 13,000 modules on PowerShell Gallery, right, that's vulnerable to this. Especially since this is new research, right? There isn't a single page on Microsoft that recommends how you should develop your PowerShell modules to not introduce gadgets. Because, yeah, this is fairly new. So no one really knows that this is a problem. So pretty much, I mean, yeah, there's a lot of vulnerable modules, obviously. But none of them have a security file, and I have another job, and it's really hard to, spending time trying to reach people. So we'll see. If you want to find CVEs, there's quite a lot of them in the PowerShell Gallery if you want to find gadgets. OK, so let's summarize what we learned so far. So we only looked at like what happens at the actual serialization. We're soon going to look at when is this actually a real problem. But if we just look at it very closely in like the actual serialization, then we see that if someone has a fully patched vanilla PowerShell without any weird configuration or modules installed, we can make an arbitrary DNS lookup, we can steal hashes, and if they use the property action, we can execute code. That's by default on a fully patched Windows machine. If they have an unpatched Windows machine, they have a bunch of other problems, but these are fairly old, so I guess everyone keeps their systems up to date, right? By a non-default, we also have code execution. So we have code execution, like I talked about, in these like official Microsoft modules and everything like that. But that requires you to have them available in your session, so it's a bit different. So I think I don't know, do you agree that it's not a good idea to deserialize untrusted CLI XML? Is that a yes? Okay, good. So let's look at PowerShell remoting. It is this thing in Windows, right? It's the recommended way to manage your IT environment. It has like that you can just invoke a command on a system. You can enter a session and get like a SSH kind of feeling. If you're using Windows Admin Center, this is what's used under the hood. And yeah, a lot of like admin tools use this. This is like the way to manage your enterprise environment. The protocol looks something like this. So it's a web protocol, and it uses SOAP, and it has like this WinRM extension, and then it's built with PowerShell remoting on top of that. And it has this like really boring documentation, but I figure it's more fun if we explain this using burp, because it's web, and everyone knows web, right? So this is me with burp doing PowerShell remoting. So we see that in the actual data that's encoded with base64 and so on, it's actually CLI.XML that's sent. That's how PowerShell remoting is sharing objects between machines. So if we run like a whoami, then it sends the whoami, and then after that you're gonna like request the response, and it sends these streams of responses, and within those streams you have CLI XML. So that's how you get that kind of awesome feeling when you use PowerShell remoting, right? Because like you have your PowerShell object, you do invoke and blah blah blah, and it just kind of works, and objects are rehydrated back and forth, and it's really nice. But didn't we just agree that you should not deserialize untrusted data? So what happens if the server you're talking to is compromised? Well, then they can send something else back. And your PowerShell prompt is just blindly trusting whatever the PowerShell session is returning to it. So that's not, that's not good. So I wanted to implement this POC, and there's quite a few challenges, because PowerShell remoting is a pretty good solution. It has quite a lot of security features. It has like this encrypted channel using HTTPS, so we can't man in the middle it. Like even if we manage to do that with certificates and stuff, then the actual data is also encrypted within the SSL channel. And it uses Kerberos, it has mutual authentication, and by the default, it only connects to the trusted systems. So basically, you can only do this to a domain joined system. And if we solve all of that, then it's still like this undocumented compression, which is just like, you know, a pain to reverse and try to figure out how that works. So I really didn't want to solve all of this, so I started looking into how else can we hijack this. And I looked into the architecture of the, you have WinRM and you have PowerShell remoting on top and so on. The way that's actually implemented is that PowerShell is a plugin to WinRM. So you can see this if you just list that VSMan PowerShell provider, right? You see the file name is that PowerShell plugin to the WinRM service. So remember that PowerShell is open source, right? Can't we just roll our own PowerShell? So I looked at the code, and I found that this fragmenter CS serialized to bytes is where we need to do the magic. So if we just do this as a proof of concept, I have this like return value, which is, you know, if I run a whoami, that's what I'm going to get. So in the other demos, we're going to implement some logic here. But we're going to reply this string instead of our username, just to see that this works. We build it, and we also build that PowerShell plugin file, and then we hook the default plugin for PowerShell, and we try it out. So we run the invoke command towards this server, and we see that we get the string back. So it actually worked. And not only did it get the string back, it also stripped away those S tags around the string, right? So we know that this actually deserialized our malicious payload. So the actual implementation of this is going to look something like this. So you have the unsuspecting user connecting to a machine they don't know is compromised. That machine returns a bad response, and something bad happens on their client. And let's take a look at a demo of this. So we can just kill that Hyper-V. And we're going to start looking at this Web 19. So here I have a Windows server, which is compromised. And it says that the VSMan localhost Microsoft plugin is pointing to my bad PowerShell. And that's all I need to do on this compromised machine. So on the other side of things, we have a domain admin here, Bob admin, who wants to run commands and do some kind of work on that machine. And the third machine that we have is this Meterpreter, or not Meterpreter, but it's a Metasploit listener to capture these challenges, right? So if everything works, we are going to be able to exploit this and get the password hash of the domain admin. And the actual exploit looks like this. We're not going to detail it in too much detail, but point is, this is where it's going to look up. So it's going to make this SMB request, which is also going to authenticate to the this Metasploit thingy here. All right, so just before I start, just to show you I'm not cheating or anything, I don't have any modules loaded here. This is just the default that you have. And the only thing I'm doing is I'm running the command hostname. I can run any command, it doesn't really matter. And as I do that, we'll see if my demo actually works. And we got the hash. So this hash here is the netNTLM v2 hash. It's part of that, creating the SMB connection. It's a challenge response thingy. But it actually contains the password, right, of this user. So we have this yon file where we saved that, and we can actually crack and get the password of the domain admin. So if the password was much stronger, it would be much harder to crack that. But of course, you can do it offline, right? Because you have captured the challenge, and you can use all your computing power to get that back. And the final thing, we can check who's domain admin using Bob admin and the password we just cracked. And we run the net group domain admins /domain command. And hopefully, we're going to get a list of domain admins from the domain controller. Or otherwise, you just have to trust me. This is a domain admin, and this is kind of outside of the point, right? So that's not a good situation, right? Because PowerShell remoting is the recommended way to do this kind of thing. Like when we at TrueSec do investigations, we use PowerShell remoting to collect data from compromised systems, because you don't want to, for example, RDP to one of those systems, because it's super bad because you expose the credentials. But it turns out that PowerShell remoting, you kind of have similar problems, right? So we're gonna, before you panic, we're gonna talk about what we can do about this. I'm not just gonna leave you with everything is burning, but it's not a good situation. And PowerShell Direct is the other attack vector of this, same fundamental technique that they use in PowerShell remoting, so they're very similar. The big difference is that they're using VM bus for transport instead of TCP IP. So it looks something like this, and it's this it's not based on network, right? So your VMs can be completely isolated. It's just going to hook into the virtual machine and talk to it directly. But aside from that, it's exactly the same thing. So it's going to take your CLI XML, it's going to return CLI XML, and that client is happily going to serialize whatever we give it. So problem here is I'm not that good with, reversing and when it comes to hypervisors and try to figure out how do I intercept something on a VM bus. That seems awfully hard. So I looked into how is PowerShell started, because that should be a user land process. That seems much easier. And it starts with this SO flag, so it's like a socket mode kind of thing. And when you look at the events prior to this, you realize that Microsoft is, or Windows is, looking for PowerShell with the search path. So what if we put our own PowerShell first in that search path? Well, then it's going to find our PowerShell instead of the real PowerShell, and we don't have to care about some, hypervisor magic. We just need to hijack PowerShell, and then we're good. So here we have a log. I mean, we can start just logging whatever is being done, because this is sort of a blind situation, right? But we can just monitor and see someone using PowerShell direct in this virtual machine, and just start monitoring and seeing what type of things are they doing. But then, of course, we can also return something bad. And the demo I showed in the beginning looks something like this. So it hijacks PowerShell XC, it runs that patch serialize the byte function, and it sends the exploit, which starts a PowerShell C2 on the hypervisor host. And since we don't have any network and we cannot assume anything, we're actually just using the VM bus channel as the C2 channel back again to get that reverse shell. And it sounds way more complex than it is. It's pretty much just a copy item. And the tricky part is kind of writing that patch to serialize bytes to allow enough of the legitimate protocol to not return our payload all the time. So you kind of need to have a allow list there to make that work. But this is what we saw in the first demo. So on the hypervisor host for this to work, they had a official Microsoft module installed. It's not default, and it does require user interaction, right? Because the hypervisor admin needs to run invoke command to make this trigger. But keep in mind that there's also backup solutions that use this. So it doesn't necessarily have to be an admin that's in there doing that. It can happen recurringly in some cases with the software installed. So I reported this to Microsoft back in March this year. And a few days later, they confirmed this as, they confirmed the behavior. And then a few days later, they closed the case without any comment. I asked what they did about it, and they didn't answer. And then I talked to my friends who work at MS and also some MVP friends that I have. And we escalated it pretty much every way I can think of, and we got them to open the case again, which was awesome. And they said that, thank you for submitting this. This issue has been fixed. And then they acknowledge it and everything and so on. But I asked, do you want my help? I mean, we can sit down and see that this patch actually works. It seems like this would be kind of trivial, not that easy to fix, because this is a very fundamental problem in Microsoft, right? But I didn't get any answer to any of this. This was the last message I got from them. So I updated my machines. Everything still worked, just as I have presented it here today. So I kind of initiated a plan B, and I started reaching out to that employee at PS Framework to at least fix that. He did a great job and started fixing it. Unfortunately, he has stopped replying since Tuesday, but I hope that he will publish a patch pretty short. But it's kind of weird that, that PS Framework, I just assumed that they would fix that because the PowerShell modules that are Microsoft official is covered by MSRC. And they have code execution vulnerabilities. But yeah, we are now 180 days into that report, so I think it's appropriate that we talk about it so everyone can start doing something about it, because there's actually things we can do to make sure that this doesn't happen. Because maybe I'm not the only one who knows this, right? Maybe this is exploited already. So if you're an IT admin, what should you do? You should start with just knowing that this is a problem. So start trying to figure out what PowerShell modules do you have on your system. Are you using PowerShell remoting from your all-in-one admin PC, where you're also developing PowerShell modules, and you have 1,000 modules installed, then you're probably really, really vulnerable to this. So you need to have a privileged access workstation that is only meant for administrating. You should have that anyways. But this just adds one additional reason for that. And I mean, as long as Microsoft does not fix the actual vulnerability, which is the deserialization of untrusted data, we're gonna, all of us, need to figure out what gadgets we have on our systems and try to diffuse those. So if you're a vulnerability researcher or a security professional, then please help me try to find all those and report all of them so we can fix the gadgets. It would be better to fix the actual root problem, but here we are. And as an IT admin, you need to update your PowerShell modules, because hopefully these will start being fixed with this perspective in mind. So that's the high level of what you should do. And if you're a PowerShell module developer, and if you're just an admin using PowerShell, then maybe it's a good idea to just avoid CLI XML. You can use JSON, for example. It's also portable between systems. I don't see any good reasons to actually use CLI XML unless you need the rehydration. Then that's a different question. If you didn't even know that it rehydrates stuff, then you could probably just use JSON, and you're not having these problems. If you develop a PowerShell module, know that if you by accident introduce a module, a gadget, then anyone who installs your module will have that additional attack surface when they use PowerShell remoting. It's kind of crazy, right? If we install a module which by itself doesn't have a vulnerability, then all of a sudden we have code execution when we use PowerShell remoting. And that's how fragile this system is, because it uses these types, right? So we need to, if we're developing PowerShell modules, we need to be really careful with our types and formatters, and think in a way that the threat actor can control all these attributes. We need to make sure that they are not abusable in this way. And I know this has been a lot of information, and I'm sure that, or I hope at least, that some of you is gonna take a look at the recommendation and do something about this, so this doesn't have to be a problem. And tonight, I'm publishing this research article. You have the link here if you want to read all the details and so on. And with that, thank you for listening.
Thank you very much. We're just going to do a quick shift and go directly, I think, into the next speaker on stage. And we're going to do some Q&A with you down in the Q&A studio as well. So, yes. So we just, if you need to go to the restroom, yes, we will be setting up on stage within just a few minutes. So. Are we getting some picture? We're getting picture there. Not there. Let's just give everyone a couple of minutes so they can stretch their legs and get a coffee. Okay, we have picture. Okay, then without further ado, a warm welcome to Chris Ferris on stage.
All right. Good morning, and apologies for being between everybody and lunch. So I'm going to just walk you through a journey of some of the major cloud breaches that have happened, and sort of the root causes, some of the themes, and really whether or not the customer or the cloud provider was really responsible for them. So who am I? I've been doing IT since the mid-90s. Mostly Linux, Unix, so I'm very infrastructure focused, not application. Started my cloud experience about 10 years ago. Pivoted into doing cloud security about 7 years ago. I'm one of the organizers of Forward CloudSec. If you're interested in cloud security, we actually have a conference next week in Brussels. That'll be available for live stream on YouTube. Spent a lot of time building cloud security programs at media and entertainment companies. Occasionally rant on Twitter. So we're going to briefly what is cloud, but then we're going to hit on the major cloud incidents, themes, really get into a little bit of how much are cloud providers to blame for this, and then a little bit on what we can do as practitioners and security people to make the cloud ecosystem more secure. There is a blog post that accompanies this on my website, and the slides are linked to at the end, so you don't need to take a bunch of pictures. So, why is the cloud different from on-prem? Traditionally, you think about network security, you've got inside the firewall, outside the firewall. You have your network defenses, and you kind of have a very two-dimensional view of things. But when you suddenly put all of your management APIs on the public internet, you make them all authenticated by a bunch of highly random strings. You no longer just need to be looking for armies on the horizon, you need to be looking for things coming at you from sort of other dimensions. So this is where multi-cloud governance can kind of get very complex. If you spent any time in the cloud security space, you would have heard of the shared responsibility model. It basically states, cloud provider is responsible for the security of the cloud. Are there badge readers on the doors? Are there generators? Do the generators have fuel? You're responsible for what you do in the cloud. Did you install an end-of-life version of an operating system? Did you misconfigure your Apache server? Orange had some great examples of misconfiguring Apache server yesterday. All of that happens in that blue section, all of that is allegedly your responsibility. You're responsible for configuring the cloud correctly. And that's sort of the liability shield that a lot of companies that are much, much larger than you are leveraging. So now we'll get into a few breaches. All of these are really documented on a website I created called breaches.cloud. There's a lot more examples, but we only have 30 minutes, so I picked some of the best. We'll start with the oldest one. Year is 2014. In cloud years, that's about 80 years ago. CodeSpaces was an SVN repository hosting company. The attacker managed to gain credentials to, quote, the Amazon EC2 control panel. This was so long ago that the AWS console wasn't even the same. They got access, and they tried to extort the company. When the company didn't buy their extortion attempts, they deleted everything. They deleted all the backups, all the production servers, all of the data that was sitting in AWS S3. CodeSpaces never recovered from this attack. They also never contacted AWS support during this incident. This is really the first moment where everybody realized, oh, we need to move to this concept of a multi-account strategy. Because when you have all of your eggs in one little billing bucket, and that billing bucket gets deleted, there was no protection, no additional authentication, no offsite backups. We actually saw this almost exact same issue play out over the summer. An Australian pension fund named UniSuper was hosting their stuff in Google Cloud Platform. In this case, Google Cloud Platform was kind of the threat actor. They went and were doing some beta software and whatever, but they had a time window where the software would shut down after a certain period of time. And when that happened, it deleted all of the online backups for this company. So for about a week, nobody knew where the $12 billion worth of Australian pension money was and who it belonged to. Luckily, UniSuper had off-site, off-cloud backups that they were able to restore from. Fast forward a little bit more. September 2018, former Cisco engineer deletes 456 virtual machines that run WebEx. That occurred 5 months after he was no longer employed by Cisco. he was identified by law enforcement by his IP address. Not the credentials he was using to delete these machines, but by his IP address. There was never any motive determined for this. Kind of leads me to believe that this was potentially an unfortunate accident. Engineer was in a system. He was like, oh yeah, I need to clean this up. Runs Terraform destroy. Suddenly he's looking at the logs and it's like, oh no. So Cisco prosecuted him. He was on a work visa. Maybe there was some, they thought they could cover up their mistakes. Because really, what we know from this is Cisco was using shared credentials. Those shared credentials weren't rotated when the engineer left the company. And to some extent, he was forced to use a system that wasn't a company system to get his job done. So 2022, LastPass. This was actually 2 incidents that culminated into a major issue. So now we actually have every password manager on stage this morning. So LastPass suffers 2 security incidents. The first one was a very targeted one related to malware. That got them access to the LastPass GitHub repository. Once they had access to the source code, they were able to kind of figure out, okay, who are the right people, who are the whales, for lack of a better term, in the company. And they identified one. So the second breach started with a senior DevOps engineer's home Plex server that had a vulnerability on it. So a threat actor managed to figure out, hey, I know who this person is. I know they have a Plex server. I'm going to get onto the Plex server, and then I'm going to pivot to their personal machine, which also happened to have the decryption keys needed to access the AWS LastPass production backups, end quote. AWS LastPass kept all of their key vaults on-prem in a data center. They only used AWS for backups. But once that DevOps engineer's keys were out, they were able to get access to the backups and decrypt the backups. Now, typically, AWS encryption is done with KMS, and with KMS, the keys never actually leave the data center. You can't get the decryption keys. You can only use the keys to decrypt the data and get the raw data. The fact that the threat actor got decryption keys for the backups tells us that they were pre-encrypting that, so good for them. Unfortunately, they were in a LastPass backup vault that a threat actor managed to get access to. No one's ever been implicated in this incident, but everybody who's researched it is pretty sure it's some kind of nation-state threat actor. Okay, Capital One. So Capital One was one of the biggest cloud breaches to date, perhaps until Snowflake, which we'll get to in a minute. The perpetrator was a, quote, former AWS engineer, which really had absolutely nothing to do with the attack, but the media always likes to say that because it makes for scarier headlines. So she discovers some kind of server-side request forgery, proxy bypass on an exposed Capital One web server. Take the proxy bypass, use that to access the instance metadata service. Get credentials from the instance metadata service, use them from her home machine. Actually, it was a bunch of VPN machines she had to look at all the S3 buckets. Congratulations, profit. Or not in her case, because she mostly just collected the data and didn't do anything with it. But that data was financial information on 100 million people. So this whole idea of an SSRF or proxy bypass with the instance metadata service has been around for a long time. First known real case of that was a Prezi responsible disclosure that happened in October 2014. But even prior to that, in 2013, Google implemented a mitigation for metadata access proxy bypass issues. 2017, Azure implemented the same. 2018, we were getting a little bit more like, come on, AWS, why aren't you doing this? So what is the instance metadata service? It's basically, it's a link local address. And it's how the instance itself knows all of the things that it needs to know about the environment that it's sitting in, what its MAC addresses are, what its bootstrap script should look like. But within AWS, one of the things you can get out of that are AWS credentials, very random strings that you can use to attack the control plane by just curling the link local address. And so this example here, basically I'm saying, hey, tell me what role I have. And then with the answer to that, I say, oh, go give me the credentials for the role that I have. There's no way to manage access to this through security groups. It's a link local address. It's managed by the kernel. It's not managed by AWS. So now we get to actually where Stockholm and me kind of collide in this Capital One story. December of 2018, Amazon opens the EU North region here in Stockholm. And it was enabled in all customer accounts. Customers didn't have the option to say, I don't need to be in Stockholm. Let me turn that set of data off. So, as I do, I keep track of what's going on in AWS. I was like, oh, new region. I better go enable all my detection and prevention capabilities in this new region. Except I couldn't, because the Two Pizza team that was launching the Stockholm region hadn't scheduled with the Two Pizza team that managed guard duty to get that service deployed and ready to go when the region launched. So I had this major gap in EU North 1 in my telemetry. Come January, I get a little bit more snarky. March. So from the indictment, we know the attacker finds a misconfigured WAF and gains access to credentials. She then leverages the EU North 1 endpoints to bypass the detections that guard duty would give Capital One and her other victims the ability to say, hey, there are credentials that should only be used inside of AWS that are now coming from these NordVPN or IP Predator VPN nodes. You should go and do something about that. But because guard duty wasn't available here in Stockholm, nobody knew the data access was happening. We don't know much about the WAF. I'm not even entirely sure that it really was a WAF. That was just the name of the IAM role that was used and what was available to us, OSINTing what happened from the indictments. But what we do know is that it had significant permissions to access Amazon S3. All right, so in May, guard duty finally becomes available in Stockholm. July, the indictments are issued. But now the finger pointing begins. Because 100 million people's credit card records are on the internet, United States Senate gets involved. And they explicitly go out to AWS and say, hey, was an SSRF actually used here? How many other incidents used SSRF to compromise the metadata service? How was AWS warning its customers about the potential threat of somebody using an SSRF to gain credentials and exfiltrate them and pull them out of the environment? And also, hey, so we know that Netflix brought this up, or at least a senior engineer at Netflix brought this up and said, hey, you know, we need a solution to this problem. So what was your response to that? So that was the question to AWS. CISO responds a few weeks, about a week or so later. They completely hid behind shared responsibility. They blamed the breach 100% on Capital One. They denied other incidents involving instance metadata credential exfiltration based on SSRFs. Further in there, they actually said, oh yes, well we tell our customers and we give them a whole bunch of services like AWS Guard Duty, and they can use that to protect themselves against these sorts of things. Except of course they couldn't, because we were here and there was no guard duty here. So Amazon opened this region, EU North 1, exposed all AWS customers and didn't give them the ability to mitigate the threat. And then they kind of threw their AWS, or they had Netflix throw their own engineer under the bus, saying, yeah, we don't know about this request. I think the actual request happened on Twitter. But we have no problems at all with, AWS. So November of that year, right before reInvent, AWS introduced the Metadata v2 service, 113 days later. Metadata v2 actually does the same thing that Google and Azure did, which is basically you have to go and get a token and pass that token as part of a header if you are going to call the metadata service. And that really bypasses a bunch of proxy bypass and server-side request forgery issues. Doesn't necessarily protect you from remote code execution. So if you can get on a box, you can use the same curl commands I had 3 slides back and get credentials and then use them outside of AWS. Luckily, guard duty is now enabled every place, and you'll get detections if you've set that up. Finally, in this one, September of 2022, $190 million class action lawsuit settled. So fast forward 2 years. June of 2021, Mandiant identified a threat actor known as UNC 2903. They were pretty much attempting to do the same thing. Uncategorized threat actor scanning AWS IPs, looking for Adminer, which is an open source vulnerability management tool. The specific version was vulnerable to this CVE that had an SSRF. So, like you see here, they point the login page to a little Python script that's returning a 301 redirect. That 301 redirect redirects to the link local address and says, hey, give me your creds. And it happily comes back as an error because adminer doesn't know what to do with a bunch of JSON. I like to use this example as the initial access method when I teach my AWS incident response class because it is a really common pattern. You've got a thing on the internet that's exposed to the world. That thing has a CVE. Maybe it didn't have a CVE when you put it on the internet, but it does now. That CVE is exploited to get credentials. Credentials have too much access. Chaos ensues. And again, exactly the same pattern as what we saw with Capital One. So speaking of chaos, major doozy here from Microsoft. And this is a failure of Microsoft as a cloud provider. The next example will be as a failure as a cloud customer. So Storm 558, attributed to the PRC, somehow obtained a consumer Microsoft services account signing key. So this is what I would use to log into Minecraft, what I would use to log into Xbox by personal Outlook accounts. But Chinese government was able to use it against enterprise production tenants. In this case, the United States State Department. Now, 558 isn't a new player. They were linked to Gmail compromises in 2009. They were linked to the issue when all of our RSA key fobs had their seeds stolen in 2013. That one isn't a cloud incident, but the RSA is an awesome incident response story and is highly dramatic. So how did they discover this? Well, Microsoft didn't discover it. In a rare good use of American tax dollars, State Department bought the top tier Microsoft licensing, which gave them the logs they needed. Then they wrote something called Big Yellow Taxi. And Big Yellow Taxi was looking for the mail items accessed call from a token that was not actually issued by their tenant. That allowed them to say, we have some very VIP mailboxes that are being accessed, not by those VIPs. What's going on here? So they notify Microsoft. Microsoft says, huh, these accesses are all signed by a consumer key. That's odd. So this was all investigated by the US Cyber Safety Review Board, which basically the only nice thing they had to say about Microsoft is that Microsoft completely cooperated with the review. Otherwise, they called out Microsoft for being completely abject in their cultural and technical risk management and deprioritizing security over features and usability. This report is also great because it's the first time we've actually seen US regulators calling out all of the cloud providers to do a better job on securing their infrastructure and helping us secure our infrastructure. And then you have a consumer key that's used for Microsoft, for Minecraft and stuff that was issued in 2016 that's being used by foreign governments in 2021 or 2023. Kind of what's going on there? Well, apparently when they tried to actually rotate this key, they caused an outage in Consumer Outlook. And so since then, they stopped rotating the key. So yes, keys that my kid uses to authenticate to Minecraft are now valid against enterprise and government customers and had been forever. So literally, while Microsoft was cleaning up the mess and responding to requests from the National Cyber Safety Review Board, Russia was getting involved. So this threat actor managed to compromise, quote, a legacy non-production test tenant account, as they worded it. And from there, they were able to pivot into Microsoft's main corporate tenant. The threat actor was Midnight Blizzard, also known as Cozy Bear, hence my picture, attributed to Russia's SVR. Their initial goal, as stated by Microsoft, was all the internal Microsoft communications about Midnight Blizzard. So, most narcissistic threat actor ever, I guess. So this is an example of a cloud provider actually acting as their own negligent customer. The initial access was the compromise of a test account. We'd expect MFA to be on all production accounts, but if I'm a user and I'm just learning how to write Terraform and creating new users in a Microsoft tenant, okay, yeah, I'm going to create a user. Then I'm going to forget to delete the user. I'm going to create another user. Mandiant flagged APT29, the Cozy Bear, as leveraging self-enrollment abuse as one of its techniques. So when you first sign up and get an enterprise Microsoft account, you have a password, and your corporate IT desk mails you the password, and you're prompted, okay, go log in and set up your MFA. So what do our healthcare data, mortgage applications, call records, and how much we're all willing to pay for Taylor Swift tickets have in common? Well, they were all stored in Snowflake, and now they're all available on the dark web because the companies that were collecting all of that data and securing it were victims of info stealers. Now, the question should be, how is it that highly sensitive personal data was exfiltrated by just using a compromised password? That's because none of these customers had MFA enforced on their accounts. Snowflake engaged Mandiant to ensure that they were not compromised. Mandiant confirmed there was no compromise of Snowflake itself. Instead, Mandiant found that all of these customers did not require multi-factor authentication, and in many cases, the credentials had not been rotated for as long as 4 years. So yes, in the summer of 2024, we still have massive data breaches due to lack of MFA. So basic themes come out of all of this. Cisco didn't invest in proper onboarding and offboarding of their contractors. CodeSpace didn't invest in offsite backups. Microsoft didn't invest in auditing its enterprise applications that had access to test and production tenants. The victim of UNC 2903 didn't invest in enabling IMDSv2. But the other set of themes here are the cloud providers. AWS didn't secure its metadata service, because if it had, even though they would have found a vulnerability in Capital One, they would not have been able to get the credentials out. Snowflake didn't enforce MFA on its enterprise customers, nor did they give customer security teams the ability to enforce MFA on their own accounts. And then Microsoft was just grossly negligent in the case of Storm 558. So this past spring, Rich Mogul and I, we came up with a universal cloud threat model. It's not threat model in the same spirit as Dread and Stride, but rather it's a way to think about your whole cloud infrastructure and what kind of threats you're likely to face. 90% of organizations will have 90% of the same problems because we're all on the same internet. So that's the core of this threat model, and it applies to more than just cloud. The key piece of this are the attack vectors. They're universal against almost all the incidents we've seen. So lost or stolen credentials, we saw that with WebEx, we saw that with code spaces, we saw that with LastPass and Snowflake. Publicly exposed resources is pretty much every time you've seen a S3 bucket negligence award issued. Creds exposed by application security flaws, that was the case in Capital One. Unpatched vulnerabilities was the case in the UNC 2903 case. This slide is from the past summer. So AWS has a customer incident response team. Highly recommend if you ever find yourself in an AWS incident, open a support case and ask for the cert. They're a free service. You don't need to be an enterprise customer. That's most of the sales pitches you'll get from me today. Of all the incidents that they have addressed, 66% of them have involved IAM access key credentials being mishandled. So get rid of your long-term access keys. The additional 13% now are things that are exposed on the internet, like that case of UNC 2903. Are the cloud providers to blame? Yeah. So Amazon says security is job zero, but really kind of whose security are we talking about? Are we talking about that of Amazon or the customer? It's clearly not job zero to have core security controls enabled as part of a regional launch prerequisite. That they'll wait 95 days for. It's not job zero to ensure that data and metadata actions are easily delineated. It's not job zero to ensure that all authenticated actions are logged and that those logs are available to us for free or not behind a very high paywall. It's not job zero to ensure that their software is compatible with their new security features. After Metadata Service v2 came out, it took a number of years before things like CloudWatch logs supported it. It's not job zero to provide free and useful cloud security posture monitoring. So yes, I would say security is job zero for AWS, but it's not the technical security of their platform or of their customers. Job zero is protecting the security of AWS's primary position among the top hyperscale cloud providers. What that means is it's time for us to demand more of our cloud providers. They need to make it easier for us to do our side of shared responsibility. They need to have clearer documentation. They need to have secure defaults. If I'm going up and spinning an instance right now on AWS, the console is going to let me open up 3389 or port 22 to the world. That's not acceptable. Because if they don't fix things, then we need to step in and ask our governments to do it. Because at this point, cloud security is becoming way too dangerous. We have folks who have the equivalent of a 16-year-old with a driver's license being given one of the most complex technical creations of modern IT and being told, try not to crash the plane. And with that, perfect timing, blog post, thebreaches.cloud, how to get in touch with me. It's lunchtime, so if you want to ask me questions, you can. Otherwise...
Yeah, thank you very much. A big round of applause. And yes, we are having lunch, and we can use both pathways to get to lunch. If you don't like stairs, we recommend using the big door here, which leads to elevators. And yeah, back in an hour after lunch. Also, we want to say that the Secti badge We're still selling it down in the shop. And up at floor 7, there's also the hardware hacking village, where there will be a workshop after lunch as well on how to build the SECTI badge. So, okay, enjoy lunch.
Hello, 3-minute warning. Time to find your seats. Okay, did everyone find lunch? Yeah, no, maybe. Okay, so our next talk is harnessing the power of machine learning to enhance malware classification and detection. I had to cheat and look. So please welcome to the stage Solomon Sonia.
All right. Thank you so much. I really appreciate SecT. Thank you so much for having me. I hope we'll have a good time with this presentation, but welcome, and let's just dive into this because I've got a lot to say, and I never have enough time to say everything. Okay, so let's get into what to expect here. Okay, so a few things, hopefully throughout this presentation in which we're talking about malware analysis, binary analysis, and then how we can apply artificial intelligence to help us detect new malware that we've not seen before. Here's the overall structure for our presentation. And so I don't have like an exact live demo, but still things can always occur when we try and show things. So in case anything shuts down, I'll do my best to recover as best as possible. But just a quick disclaimer, at least the views and everything that we're talking about, they do not represent the views of the United States Air Force or the Department of Defense. It's just my personal research that I'm doing on behalf of my lab and my university to hopefully be useful to our cybersecurity community. Okay, so research motivation. Now, I have a couple of quotes here. One, we say any sufficient advanced technology is indistinguishable from magic. I really like that phrase because sometimes when we talk about artificial intelligence or machine learning, it seems like we're sprinkling magic on something and saying we're using the AI to do something. But overall, I'd like us to understand, like, how can we convert data from whatever we're looking at, how can we feed it into models to give us useful detections and useful decisions? And so that's what I'm trying to say here. The goal is just to demystify how we can apply artificial intelligence into our current research. Okay, did I go back? Okay, so one of the questions, sorry, yes. All right, so one of the questions that can be asked, because like we've been using artificial intelligence, machine learning for malware classification for a while. Now, some people might say, you know, okay, let's address the elephant in the room first. So some will say, well, in our enterprise, in our environment, we have antivirus, we have SOX, you know, your Security Operations Center, we have compliance, we have next generation insert appliance here. You know, this is sufficient in order to help us detect new malware of tomorrow. Well, that's possible, but I like to have a chart kind of to set the stage. And so VirusTotal, hopefully many of us, I mean, if you're at the conference, most of us are familiar, at least with who the entity VirusTotal. And so they have a dashboard, like every day, that they explain how many new malware samples that they have received. And so across an entire month, you can see like the overall trend of which malwares they are receiving, and then how many are new or distinct samples. So as of July, and even July going into August, August going into September, this number has constantly been increasing, in which they say per day, they receive over 2 million, on an average, over 2 million samples for analysis. And of those 2 million samples, 1 million, over a million, now we're at 1.8 million distinct samples are provided to VirusTotal daily. And so something to keep in the back of our mind is, okay, how often are our antivirus or our compliances that we have and use, how often are they updated in order to keep up with this trend of nearly 2 million unique samples that are created every single day? So overall, it's not an industry problem that we just need to buy some product. You know, it's something that many of us can research, and we'll have to continue to always be researching in this area to hopefully stay ahead of the adversaries. And so this is something that I posit. I say we need new strategies in order to help us better detect malware of tomorrow. And I believe those new strategies lie in the incorporation of artificial intelligence, machine learning, and even natural language processing. Okay, so let's get into the formal problem description, or the formal problem definition. There are 4 main ones. That's kind of the overarching guide for the entire presentation and the research that I'm doing. Number 1, there lacks an overarching description of how we can take malware and binary samples apart, how we can analyze these samples statically, dynamically, and even extract artifacts from memory, and then have a uniform language that we can use to describe these samples. The second one, there lacks a robust framework that's able to automate this entire analysis pipeline. So again, we can get that aforementioned data set standardized in the right nomenclature that allows us now to pivot into artificial intelligence and machine learning modeling. Number 3, there also lacks a large updated malware analysis, like a data set or a benchmark that we can use to continuously adjust our models, evaluate our models, and make things better for the future. And so that's an important point, because if we do a literature review on current people that are doing research in malware analysis, research in artificial intelligence, et cetera, something you'll constantly see is the data sets that they are using in order to evaluate their systems and their models are very old. Some data sets, even in research that I was analyzing as of just last year, 2023, they're using a malware benchmark that was created in 2010. And so malware has advanced since then, but we're still using data sets that are over 10, almost 15 years old. And so we need to constantly have a framework that can help us update this data so, again, we can make our models better. And then the last one, that also lacks an ensemble, a heterogeneous ensemble that's able to increase that detection and the precision with high accuracy. And so overall, overarching, like I said, what we are doing in our research in order to help the community. Okay, so something I'll mention many times is model. Model, model, model. What is a model? So we start with the model. Okay, so if we just define this quickly, a machine learning model, it learns patterns from data, and then it uses or creates a mathematical function that can help us make predictions. And so if we look at a supervised machine learning model, we can try and find a relationship between our given features and then the response variable. So let's look down here. In this case, let's say we have a linear function that we are analyzing, And so in a linear function, we want to understand the weights that are applied to each of our input variables in order to help us predict the dependent variable. And in the slides, I use this y hat, which is common nomenclature for us to discuss. This is our prediction of the function for the variables that are coming in. Because if we can understand this part, then we can see how to better apply these models to various data sets. Now, if we expand a little further, let's say that this is our input. So input here as a scatter plot. We can say this represents, let's just say it's years of children, like their children age development. And then here we want to understand what's the normal height that the child is supposed to be at a specific growth year. So we can look from history, we can look at historical data to understand and try and find that, we call it the best fit line, or a regression line that can help us understand, like these are my input variables coming in, and then if I can figure out the weights that are applied from our history, we can now use that to make decisions moving forward in the future. So overall, we're looking at data that we have, we analyze it, and then we try and find that best fit line. When we can do this time and time again, and then when our prediction is really close to what our ground truth should be, we now say our model generalizes to new unseen data in the future, and then hopefully we can trust that to help us make decisions moving forward. Okay. Now, let's talk about models to know. So if we're getting new, or if we're just getting started into this domain, I try and put a few to just start to be familiar with. So if we understand a few of these models, like learning and reading more of these in the future, it's actually much easier. And so when we talk about machine learning tasks, the two ones that we'll discuss today is supervised learning and unsupervised learning. So when we discuss supervised learning, we mean it as all of our data sets that's coming in, it's fully labeled. And by a label, it just means if I have different features that are coming, I also have a label or a classification, for instance, of what should the ground truth be. So again, I can learn from historical data. I can evaluate my model to the historical data, and then it can tell us if it generalizes. So if we can generalize, we say we can trust this model and use it to make new predictions on unseen data for the future. So under supervised learning, there are two main ones, classification and regression. So when we talk about classification, it's just we want our model to tell us if I give you a sample with a specified feature vector, like here's the size of the sample, here's code that we've seen inside the sample, here's what its imports look like, et cetera. Those are features to describe a sample, an instance. Then we want to determine, is this sample malicious? That's a classification, yes or no. Or does this sample belong to a specific malware family? Malware family attribution, that's a classification. So on the previous slide, we spoke about a regression. So if I give you continuous data, I want to be able to predict where that, the future data or the future prediction, what that should look like. And so again, we can just research these. There are very many YouTube videos that can help us see how do we apply these different models given the data in order to help us make predictions. That's supervised learning. Then unsupervised learning, we don't really have a label or a prediction. We don't know what the data should be. We're just analyzing to see, okay, what are some of the trends? What are some of the associations, some of the clustering that the data can help us provide? And so there's no time in our presentation to talk about unsupervised learning, but your two main ones that we'd care about is clustering, as I said, like an association, or some dimensionality reduction if we just want to reduce from a higher dimension space to a lower dimension space to keep our models as simple as possible to help us make the better predictions moving forward. Okay, now let's get into our machine learning workflow. And so I put this workflow together kind of as a general guide towards, okay, how do we now start to get closer to applying this analysis approach to help us make predictions? So the first thing we always start with some sort of understanding. In the literature is referred to as business understanding. And so then the business understanding is just when we have some data that we want to go after, or we have some data that we want to analyze, and now we start to see what do we want to extract in the data. So again, we're working on malware classification, so if I have many malicious samples, one of the things I want to extract are the appropriate features to help us classify the data set. So we just know, like, what might we have, and then what do we want to do? We start to form also some hypotheses that can help guide our research. Then we go towards the data collection. So the data collection, if you're lucky, you have structured data, which makes it easier to feed into the models. In the real world, the data is it's noisy, it's messy. And so now we have to use some code to try and clean it and convert it into an appropriate structure so we can begin our analysis. So we gather, we have some area where our data comes from, then we move towards our data wrangling. So data wrangling, other literature will refer to this as data pre-processing, and that's just where we have some data that we've procured, and then we do some exploratory analysis. We may refer to this as EDA, exploratory data analysis. Now we're trying to figure out what are some general trends in the data. So if we know the trends in the data, we might be able to already start to identify what specific features might we want to feed into our models. Then we go towards some augmentation. I might want to add some features together or do various functions, and I'm cleaning the data set in order to get it as close to what our general models need. Now, if we say what our general models need, it's usually like a table or a matrix. You know, I want to go from some unstructured data, I want to structure this towards my feature engineering, and so it's like a table or an Excel worksheet that kind of has my features if I'm doing a supervised type of learning. So again, we can feed it into the models that already exist. Then in our feature engineering, when we understand the data, we can start to see, all right, these are some of the features that I want to clean. I want to make it as pristine as possible, and I'm ready to feed it into our models. Sometimes in our feature engineering, we might also delete a lot of the data that we've received because too much data can actually contaminate some of your models. So we want to be as clean as possible before we get into modeling. And now finally, when we're at our modeling step, this is where we have our data, it's organized, it's as clean as possible, we're starting to feed it into our models to help us make decisions. Now if we say, whenever we do this type of, like people discuss artificial intelligence, machine learning, it seems like it's a sexy thing to do. Like my models are learning stuff. This is actually the most boring of the process. 80% of our time is spent converting our data in order to get it into modeling. Because really, once I send it into the models, I actually just have to wait. Sometimes you might have to wait 20 minutes. Sometimes you might have to wait 20 hours in order for our models to learn from the specific features towards making predictions. Then, after our models have made predictions, we go into our evaluation. And so the general terms that we use in evaluation is an objective function or a loss function. Did I put it loss function? No. Okay, so a loss function or an evaluation score. So if I have multiple models that I'm using to make a prediction or decisions for us, we now need to evaluate how well do those models perform. And so that's what this evaluation score will give us. Well, it has the smallest loss to the ground truth that we've analyzed before. Generally, the one that performs the best is the ones that we will use in our production environment. Then after we do that, we go towards our model selection. We select the model or multiple models that are as close to the historical data that we've analyzed, and now we move into our production. So our calibration, sometimes we may have to actually go back and make sure our models are correct, or we may have to adjust some things just to fine-tune the model when we're ready to deploy it. And then we deploy, we look at it, we do maintenance, and then you start the process all over again. Okay, now, if we've understand the foundation of the background, let's get closer to actually analyzing our malicious samples. And I'm looking for a timer. I don't know how much time do I have left? Yali, normally over here. Did you get a timer? Timer started? No? I'm sorry, what was that? 30 minutes? Okay, all right, good. Yes, so we are, all right, we're good on time. All right, so now let's, as I said, we're moving into our multinomial classification, and this is where we could have multiple classes that we now want to analyze and say, okay, given an instance, which specific malware family might it belong to? Okay. So to start with, if we look at a PE, like a portable executable, a Windows binary, the Windows binary structure is rich with features that we can analyze. We can extract these features. We can understand, okay, the same, like as I mentioned, size, like import address header, the actual object code, the way the code is written, all of these are features that we can standardize. So we can extract these features, we can standardize it. As I mentioned, we go through our workflow, then we can feed it into our models to determine, okay, what specific family might this malware belong to, or different characteristics about the malware. In reverse engineering, generally whenever I have a sample that I'm analyzing, I pretty much look at these 6 main areas to help me know what is that sample doing. So the first one is like the metadata. So like as I've said the metadata a few times, we can also look at the function's hash, or fuzzy hashing, just what is the composition of the sample itself? Well, those are features that we can add into our model. Another one is library functions. The library functions, if we can extract the library function statically, we can use those in order to infer potential operations or capabilities of that malicious sample. These are features. If we look towards its system calls, as we get lower level between the actual binary and the kernel or the operating system calls, we can also use those to describe a binary. If we look at these, if you look at many binaries of a similar family, you will generally start to see similar patterns. So what we want to do is extract these patterns and now put it into our modeling to help us detect these in the future. Then we can get into deep inspection of the actual binary in which we're looking at its functions, its composition. So we can use another type of artificial intelligence like natural language processing in order to start you can use natural language processing like for speech. How do we talk? Which sentiment is similar in what people say? Binaries have the same thing. There are strings, there are words inside binary. Its actual code follows a structure. So we can understand that structure. Again, we can start to cluster and see the associations and the similarities between different malware samples. I mentioned strings before, and then event tracing. We can now, besides looking at the sample statically, we can execute the sample and look at what overall does it do when it's running within a specific time window. And then if you do these time and time again, you again start to see patterns of what specific malware do. Generally, once it's instantiated, it's running, it's operating on the system. Well, what all does it do? Does it look to enumerate the hard drive? Does it now call some cryptographic functions? Do you then see files that were enumerated before? It goes through a cryptographic function. A new file is written, and then the old files are deleted. This is a common paradigm of like your ransomware. So if we can understand these traits and how it executes, as I said, we can use these as features to feed into our model. Okay. Now, I want to leave just with this quick reference. And so when we go into the modeling, so we understand features. Now we look at, okay, well, which specific model or what model types should we use? I would like to reference this entire book. And depending on how good your Google is, you can actually find the book in a PDF version. But this book it's like a Bible of many different research and analyses that people have done in various areas. And so I'm working on many of these, and so that book, like at least if we can see what people have done before, it makes it easier for us to apply this into our own specific domain. Okay, now let's look into our feature acquisition. So show of hands, VirusTotal, are we familiar with VirusTotal? Yeah, that's most of the room. Excellent, excellent. Okay, very good. So if you have used VirusTotal, here we have a sample that we've submitted to VirusTotal to determine is that sample malicious. The first thing I'll always look at when I submit a malicious sample to VirusTotal is how red is it? The number of detections that we have given the number of antiviruses that are plugged into VirusTotal at that time. And so here we see like, for this specific instance, I can't remember the type of binary that I used, but 60 out of the 69 AV vendors, 57 of them said that sample is malicious. So yeah, we can pretty much conclude this sample is malicious. Okay, very good. Now, if we look down towards the data that VirusTotal provides, these, like the metadata, descriptions of the binary sample, that's metadata that we can use into features. Looking at the library functions as potential capabilities and the way that malware can operate on the system, library functions, these are features. And then the same thing on this side, like its behavior. So I'm not sure if VirusTotal actually did a deep inspection of code, because I do that as well. But at least they can give us a summary, even attaching this to MITRE ATT&CK framework to say, these are similar things that we've seen in this specific sample. Those two are features. Okay, good. So now you're already familiar with looking at features. Here is the problem with using a tool like VirusTotal for your feature extraction. Well, access to large, commercially available data is generally expensive. And so how expensive do we mean? In our lab, we have terabytes of malware. So terabytes of malware, that's thousands and thousands of unique malware samples. I reached out to VirusTotal to say, hey, I really just want your antivirus detection so I can kind of just use this as ground truth. Can we partner? Like, what does it look like if I submit your samples and then I can just automate the process, so I can go back into our artificial modeling. VirusTotal comes back and says, access to our data costs hundreds of thousands of dollars. Hundreds of thousands. Like, I don't have yet hundreds of thousands of dollars to submit just because I want to see your ground truth samples of malware according to the corpus that I have. So when you don't have an easy way of extracting your features from another created repository, then it just means we need to create that analysis ourselves. And so here's what that analysis pipeline looks like. We start with a malware corpora, multiple corpus that we have. And yeah, I think in one of our next slides, I actually list the different really good repositories for getting just large samples of malware. So for each malware that we have from our corpus, we now want to analyze this and automate our process. So we want to write an agent that helps us to extract like the metadata, the features that we spoke about before. Then when we know the features that we want to look at, we do have to do some sort of normalization and reconciliation. Like compilers might use different forms of optimization whenever it's compiling its code. So we kind of need to reconcile how some of our features are extracted just to make sure it's as normal or standardized as possible. And then we get into our knowledge-based translation. And I'll explain this a bit more in the oncoming slides. But at least starting from an executable, we can abstract the features that we need into our specific areas that we spoke about previously. And then this is ready to be fed into already existing machine learning models. So if we can do that, then now we can already feed a brand new sample I've never seen before to start to say, models, do we think it's malicious, yes or no? Or if we do think it's malicious, what specific malware family might it belong to? Or perhaps we can establish code prevalence, in which we're seeing like these code has been shared between different malware samples, just to help us detect things that we've never seen before. This is generally what that pipeline can look like. All right, so on the previous slide, you did see like there was a red square in terms of like how do we get closer to creating our features, all right? Let's go a bit further. So as I mentioned, these are really good sites for malware repositories. VX Underground is my favorite, as well as Malware Bazaar. You can just download their entire repository, get gigs and gigs, and end up with terabytes of malware. So again, for each sample, we can now write an agent. And so our agent is our binary analysis orchestrator that's going to analyze each sample. And then on Remnux, I wrote the agent on top of Remnux. Remnux is an incredible reverse engineering malware analysis distro that has many tools already created and populated in this distro. So we can learn how to use these tools, that we can use an agent to automate those tools and then provide us specific amounts of data. Now here, I put my favorite specific tools used by our agent in order to help us analyze the sample, such that if you wanted to go off and to be able to recreate this entire process, these are all of the tools we want to show you as much as possible. Then, as our agent is analyzing or launching all these various tools, they're going to give us data in disparate formats. So then we just want to take a step back and understand, what am I looking at? So we can go from these specific tools to give us like this type of data, like our metadata that we want, our sections and our features. Disassembly, these are really good tools that you can automate. And then, just moving down, we want strings, we want signatures, compilation data. These are the tools to help us kind of summarize the details that we're extracting from a malware sample. And then when we have those features extracted, we now introduce another agent called our file descriptor that helps us look at the data that's extracted. It puts into our knowledge base. And then we take data from our knowledge base to translate it into a matrix. And so if we can translate our data from an executable over to a tabular form, then we're ready here to pivot into our machine learning pipeline that we spoke about before, and then our final deployment with a classification agent in between. All right, let me try and help show that one more time, just one more quick dive. So here we're using two tools from our agent. So Manalize is a great tool on the Remnux distro. It can just give us lots of metadata about an artifact, like for instance, its DOS header, PE header, its image, optional header. All of these, as I mentioned, we can standardize the same artifact from different samples. We can use these as features to feed into our models. And we can do the same thing even with the composition of the disassembly. So when we take that, hopefully this makes sense now of going from that sample, the corpus, binary, orchestrators, into creating our table. And then once we have our table, you're now ready to immediately feed these into various models for classification and analysis. We've also looked through every is That's a loaded word. But all of the malware associated to a specific malware family from VX Underground that we spoke about on one of our previous slides, we analyzed that, and then we've actually released that data set to the community. And then if you like, you can go to our GitHub here under the National Science Foundation to extract the data set. And so this data set you can immediately pivot into different types of learning. And then also towards the end, I'll talk about the GitHub in which I will be uploading the notebooks that you can do this directly. So I want it to be as quick, as click-friendly for you, and I'll try and annotate things as best as possible. So again, you're ready and you're able at least to start playing around with these models to learn more. Wait. Yep, and I just spoke about that. That will be on GitHub. Okay, now I want to also apply image casting on convolutional neural networks. I want to talk about that real quick, but I don't know how much time we have left. So I usually started. I just missed starting the time. How much time is left? I'm sorry? 10 minutes? 18. Okay, okay. All right, good. All right, we're progressing well. All right, so let's talk about this. On this slide, so a convolutional neural network, I think if we've heard the terms artificial intelligence, machine learning, CNN, convolutional neural networks is one of those artificial neural networks that has been mentioned. Like, we use this really, really well. It works really nicely. So the normal domain for a convolutional neural network is kind of like for image classification and textures as well as edge detection. So here we are. We have this type of deep learning neural network that we can use to classify different types of images. And then the general input is like an image, a video, or even audio data types. Facebook, or let's just use Facebook for instance. Have you noticed that on times when you're on Facebook, you upload a picture, and then Facebook will say, hey, I think this is a friend from your picture. You're like, well, how did it do that? It's actually using convolutional neural networks in the background. So it's learning features from the image that is received, and then it looks at all of the images that it has before where people have tagged it. And then based on the similarities, it says, I think this image that you've given me is this person. Sometimes it's way off. It can say it's a statue. It can say it's something random. Or other times it's actually close. And the longer and longer we have data that's uploaded to things like Facebook or other social networking sites, the more precise it's going to be. But that's what's working in the background, large convolutional type of neural networks. All right, let's get a bit further. So I have another example here that I'm just showing where we start from an image. So over here can be like a car or a vehicle. Inside a convolutional neural network, there are multiple setups that we use for that convolutional neural network. So we start with an input layer. And so the input layer is the image. So if I have a picture that I'm sending into our convolutional neural network, that image is generally multidimensional. And so that image has a height, a weight, and then there could be multiple channels for each color. Like your RGB, red, green, blue, the color that composes the image, we can actually extract those, but each one is a specific dimension. Then we go into our convolutional layers, our hidden layers in which we convolve the image. So convolving the image, this means I have a filter of a specific size, and then I'm analyzing, I'm scanning the image to understand like what are the unique things that reach out to us. The more individual layers that I have, or perhaps another example is if I have a straw, I can only look through a straw. So if I have my entire image and I have a straw, I can look through at a specific time. My convolutional neural layer lets me see at a specific width or window that I'm looking at, what are the features there. So as I scan the entire image with multiple layers, I'm now starting to see, okay, here are the unique features that are sticking out at each window size. Then, from our convolutional layers, these are usually attached as soon as you do a convolution of the image. I'm just filtering, looking for specific features. We then have an activation function that's associated to that window. So the activation function, it allows us to introduce nonlinearity in order for us to determine or figure out more complex images or more complex features from a window that we're looking at. Okay, then from that aspect, we now have pooling layers. So each time we do our convolution, we're now getting still more and more layers. So our pooling layer kind of helps us flatten the image or flatten those layers to make it more simple again. It also helps us reduce this term overfitting. I should have written it in here somewhere. Overfitting. So overfitting, this is when our models, they learn too much from our training data, but then when I give it data it's never seen before, and our test set is not able to generalize well. So if I have a really granular or pixelated image, I can send this into our convolutional neural layer, but like the specific, like the distortions in an image, we don't use a distortion like, if someone was running and you take a quick picture, it could be blurred in the background. But we don't use the blurring pixels as a classification mechanism. You want to look at the colors that are specific. So that's why we have our pooling layers that helps us simplify that. So again, our convolutional neural layers, our network here, it throws away some of the distortions so we can simplify the image. Then when all of that is done, we have many layers in between here. We start to go towards our fully connected layers. So our fully connected layers, this is where you would generally have like your multiple dimensions down to 2 dimensions. And then we want to go from our 2 dimensions, again, we're simplifying this, to 1 specific dimension. And so the word flatten, flatten, right here. And so as I mentioned, if you start with a multiple dimension image, I now just want a single 1-dimension feature vector, a really large feature vector that says these are the unique features that we're able to identify for each object that's going in. Now we can use those specific detections. There's light, there's an edge, there's the dimensions of where one eye is from the other. We can use these to help us identify similarities in other images that are going through. Okay, so that's just the general domain of a convolutional neural network. So how do we apply this to malware? All right. So it's right here. So I still find this very, 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 very fascinating. So we can take a binary, a malware sample, a Zeus bot, Dooku, Flame, etc. We can take that same executable and cast it to an image. So that means the bits that represents the image, I can now use that to create some grayscaled image here. And so this is what we have, 1, 2, 3, 4, 5. These are 5 unique variants that belong to the Zeus bot family. When we cast these into an image, it's just zeros and ones, grayscale, because we want to have as few channels as possible. This is what some of those samples actually look like. I still find this even as I'm talking about this, and I did it, it's still interesting. But if you look at these, even with our own eyes, you can see similarities. So that means if you can see similarities within various samples, then we can use a convolutional neural network also to find the similarities of those same samples, but at a more fine tune than what our eye can ever see. So if we can do that, then we can build our entire model to recognize the textures from previous samples, and then we can also add this as a selection or a classification mechanism to detect new malware of specific variants that belong to specific families in the future. Okay, I want to introduce you to deep image search. So deep image search, this is a framework that has multiple convolutional neural networks built in. And so as I mentioned, I want this to be as applicable as possible. So on your environment, you can search, you can Google, what is deep image search? And then you can figure out, or you can see kind of how can I use different models within this framework. So here I'm just saying it's a Python library, uses deep learning for image retrieval and similarity searching. So we can use this as a framework of many other models together, kind of in a unified manner, to do our malware classification and detection in the future. Now, in the slides, I'll be sending the slides like right after the talk or so. I actually go through how you can start to finish to take malicious samples, cast them to images, like this is really the code to take a malicious sample here and then cast it into a specific image, and then we start loading it through the entire framework. And so also on GitHub, I'm putting this up. So the images that we're starting with here, it's just called grayscale, and then that's the password infected. So at least I can put it onto GitHub or Google Drive, and then you can download it without the malware proliferation error alerts that I usually get from these sites. So to start with, we'll look at 23 unique families that are inside this set that you can download. Within the family, we have between 4 and 7 unique samples per family. Altogether, we'll have 154 images that we want to identify and classify. Now, in the slides, as I mentioned, I have exactly how you set it up, but I want to go to the end because, what's the point of looking at code? You can do that, on your own. But I'm just saying, I try to tell you how you can set this up. But let's go towards the useful aspect of it. So the useful aspect is here. Okay, so after we load this package, Deep Image Search, you can specify which specific convolutional neural networks that you would like. Then inside the code, I made it as click and play friendly as possible. You send your images through the different convolutional neural networks, and then it will give you a classification. And so as we do this more and more, we will start to see how do we evaluate which model is better. Each model here, these are the model names, and I just used a few just because it's going to take some time to train. But each model, they are able to find or identify image features specifically in the data set. That's why we use multiple ones to say, okay, which is the best? Different classes or different malware variants have different ways of, they have different features, but different models are able to identify these features differently. And so here we want to look at the best model for that specific class, and then we incorporate this into our classification. Now, I'll move forward. So here's something also that we're able to do with this. So we're able to give it a specific malware image, like that Zeus here. I'm just saying it's at index 109. And then we can say entire framework, give me the images, give me the malware that are similar to the one that we just said. And so it can also give you those images. And then, as I mentioned, it's really nice being able to see that, yes, this does a pretty decent job at identifying the similarity in malware. So we can also use this for code similarity and classification moving forward. Okay. Now we'll go towards kind of the overall summary, and then I think we'll be done. Can you give me a time real quick? About 7. Okay, good. Okay, so here, when we do multiple models, so you don't have to worry too much about the words here. Just know that each line represents a specific model. And then on this side, we're trying to say how well that model performed in the classification of images that were fed to it. So generally, whenever we do this, we use multiple models to make a decision. We look at the evaluation of how each model did, and then you select the best model, and now you use that towards your operation. We already spoke through that about the classification, then our workflow at the very beginning. But I want to say that, yes, we can get models that are quite good. Just know, this is a number. This is the best model from our entire framework that we're using, but we can actually be better. And so this is why I'm talking about the concept of the heterogeneous ensembling, or a heterogeneous ensemble learning. So anytime we talk about an ensemble, it just means I'm taking multiple models, we call them weaker learners if they're not specific, to do a really good job. But I can take weak learners, I can aggregate their classifications together to develop a strong classification mechanism. And so that's the whole purpose of creating that heterogeneous ensemble. So here, this is very similar to the previous slide that I mentioned before. These are different models that we have. Now we're using more models on the data set that we've released, and we said it's part of the National Science Foundation, Mabel data set. You can already take those. You can use the workflow that we'll upload onto GitHub, and then you'll be able to recreate this process. So here we're seeing how each model performed, and then this is the overall evaluation score for each model. And at the top, your general process is we look at multiple models, you select the best model, you move those forward, but we can be better. And so I'm showing here that if we know how to pry inside the performance of each model, we can now use the entire model space to help us identify what is the best classification moving forward. So again, instead of looking at one model, this is usually the best overall model, but if we talk about a specific class, that best model is not always good in each class. That's why we spend time to analyze how well does each class perform, and then you select the best mechanism from those classes, and then you move forward. The literature, you'll generally see this referred to as voting or stacking. And so here, we're just trying to say that voting or stacking, that is a really, really good approach, but it's not always one or the other. There are times you have to blend those approaches in order to give us the best detection mechanism. So I'm just going to show quick results that here, just again, these are words. These are different strategies that we've built in order to help ensemble different models together. And then inside these, we have that agent, our classification arbiter, that we have to program in prime directives of how it makes decisions in order to look through the models. So you have artificial intelligence that's looking through your data, it's making decisions, and then you have a separate agent that has directives on how to look at the models, on how we go towards our classification. And then as we've created our heterogeneous model, we are already starting to see like the better impacts with our ensembling than from previous. So there is utility in being able to apply artificial intelligence towards detecting what we know and things we've not seen before moving forward. Okay, so now we're going towards the summary. As I mentioned, the code will be uploaded towards GitHub. I think I should, depending on how tired I am when I leave here, I should be posting the link hopefully in a few hours or by Monday or Tuesday when I make it back home. Yes, yeah, and then the last thing. So I remember my journey when I got started into artificial intelligence, and the spoiler alert is it's a never-ending journey. But for people that are interested in like how do we get started, like what are some of the things to do? Okay, no problem. Well, I put kind of the best resources that I found that I think is pretty, standalone. That if you start in reading one, you can already start to implement this type of modeling and detection in order to have like artificial intelligence into your respective domains. And so there is a little knowledge that's needed. We do need to know a little bit of math, at least to evaluate our models. We do need just a little bit of programming, but there's so many resources to help us with how do we just use Python in order to help with our machine learning process. And then there's education I mentioned. Some are like you might have a week-long boot camp that's like boot camp for artificial intelligence. A week is too short. But at least take some time, and as I said, it's a never-ending process. But some of these resources are really, to me, they're really good. And then I think in the slide you can actually click on these and it'll take you to the Amazon, or depending on how well you can Google, you can find all of these online as a PDF. And so hopefully these just leaves resources to get started and then to better understand your artificial intelligence in your domains. Okay, that is it for now. I don't know if I have time for questions, but are there any questions? Thanks.
Thank you very much. We are going to do a recorded Q&A with you afterwards. Now we're taking a 15-minute break before the next talk. So please grab some coffee or some club mate to get your energy up this afternoon. And see you back in slightly less than 15 minutes.
All right, time to go. Oh, Jesus. Time to come in and have a seat. Find your places, folks. If you were not too awake before this, you're going to be certainly awake after this, I'm sure. I'm going to hand the stage over, and I'm sure they can introduce themselves perfectly, but we have Juhoi and Stack.
Good times. This feels great.
Yep.
Okay, so we got about 258 slides to go through in the next 45 minutes, so buckle up. I'm Stig, this is Juhoi, and we're actually here because we are on tour for the release of our new album, Pure Scandinavian Darkness. Pretty sweet. No, I'm kidding. We're actually here to talk about space weather and heat and voltage and other stuff that makes your devices and mine go haywire and spit out things and fetch resources, leak credentials, and send emails to places that they really weren't supposed to. Like this nice Slack token invite, right? That's cool to have.
Yeah.
And if we take a closer look to this, isn't that really close to the company that you work for?
It actually looks like, but it's a Q instead of A there, so it is in fact a typo. So if we inspect our keyboard here, Q is basically straight next to A. And this is just what happens when you misplace your hand on a keyboard and you know typos. This is a typo.
And that's not what we're going to talk about. We're going to talk about bit flips, but bit flips is kind of like typos, but for computers, because no humans are involved in this. And what's really cool with bit flips is that it takes just one bit to change everything. Because if we take this G in Google here, for instance, you can see that that's built out of all these ones and zeros here. And we flip this one here from 1 to 0, it turns into Google. And if we change these two here, well, that's Google. And then you can go down here and change that one, and it turns into Woogle. And since we're speaking about Woogle, if this was WordPress and you change that W to something else, a 0, it would be GordPress. And you can actually buy that domain if we want to, because it's one flip away.
Actually, you can't anymore because we did this presentation in Black Hat a month ago, and that domain is not available anymore.
Somebody actually bought it. I think it's Ming, though. So anyway, and that is something called bit squatting. And bit squatting was a term that was coined kind of by Artem Dinenberg at DEF CON 2019, and he made this really cool research paper that explains everything, right? Super cool. And if we dig into the whole term bit squatting over at Wikipedia and actually read, it says, bit squatting is a form of cyber squatting which relies on bit flip errors that occur during the process of making a DNS request. The bit flips may occur due to factors as faulty hardware and cosmic rays. And I'm like, cosmic rays. And got super nerd sniped by Dylan Avery because he told me that he bought GoogleAPIs.com, which is one flip away from GoogleAPIs.com. And due to what he said, cosmic rays, he got a lot of loot. And with loot, I mean API tokens and leak credentials, JavaScript fetches that he could inject stuff in, and I'm like, oof. I need some of that. And so I asked him, like, how can I do this? I want to do this too. And he's like, oh, it's super easy. Just buy a couple of flip domains, catch all the DNS requests, write some simple code to do shit with it, and store it in a log file.
Yeah, simple, right?
Simple. But since all of you are smart people, I figured that I'll just break it down, the classic DNS HTTP flow on a client for you, so we all understand how it works, because it wasn't really clear to me. And it's important long down the road. So let's say that we want to have like this OAuth dance, right? The client would then want to authenticate to, in this case, let's play around with WordPress. So it's going to connect to this upline DNS. That upline DNS is going to talk to root DNS, and that's going to start with a nice NS record with the name server that's authority for that. That server is going to respond back with an IP address for that particular domain. And the client is going to be, oh, cool. That means that I can send a request to this web server. It's going to get a response back with some kind of token thing in this next part of this dance. But imagine for a second now that it flips in the memory of the device. This is pre-flight. So now it flips. WordPress turns into GorePress. What's going to happen now is that it's going to do the same DNS request upline, and then another server is going to respond. Super happy and say, yeah. By the way, this is the address that you're going to go to. Different one. Client, happy, sends the request to the server with all the handshakes token and all that mojanga.
Yummy.
Yummy.
Extra spicy.
And that worked great shitload of years ago. Then somebody thought that HTTPS was a cool thing. So boom, that's going to happen if you don't have the right certificate for that kind of domain. So, and if you're hosting it on your server, you need to do kind of all this. I realized this was all I had to do. Like buy the right flip domain, set up a bind9 catch-all DNS server, Nginx and a proxy, add some dynamic Flask code to it, and store the HTML with log files, and then generate a lot of Let's Encrypt certificates, and renew those every 90 days. And just to explain why certificates is a hard thing here, we need to understand that if let's say that I get an authentication for this auth domain, right? That means that the certificate I need to provide need to contain any of these pre-staged SON certificates for the connection to be correct. But there's also another option, and that's to have like a wildcard certificate, right?
Yep.
And a wildcard certificate, in this case, it's start at GorePress. And what that's going to do is that it's going to like allow any of these first level kind of things like www and blog and whatever in there. But if the request is let's say auth.dev API, well, that's going to be a warning for you again because you only had it for the first layer. So you need another wildcard certificate to cover the rest of them. And that's going to be cool because then the request is going to go to GorePress and that one, and you have this extra one here, and yeah, it's all fun.
Yeah, the DNS zones can be vast. Like people really, really love to add like a subdomain of a subdomain of a subdomain nowadays.
And if you work with any kind of modern web apps today, they have these like EMEA, dev1, blah, blah, blah. It's like very, very long. And guessing those can be tedious and takes a lot of time. And every time you needed to make this kind of text record, and then you had to add that into the Nginx, and then have that in the routes manually, and then renew those every 90 days. That was a tedious process. So I figured that, hey, why not just automate the whole thing? That's going to be great. But I wasn't really happy about the whole automation process, so I put on sunscreen and did something else for about 2 years. I forgot about the whole project. I got the box up and running to one day when I got this nice message from my VSP provider that says, oh, your Flippy McFlippy face is running out of disk space. I'm like, oh, what? What's that? Interesting. So I logged into the shell and looked at the box, and lo and behold, it was out of disk space. I'm like, I wonder what's in there. So I looked into my cache log file, and that was full of load. So I was super happy and like excited about it.
Yeah. So meanwhile, I have a small story to share as well. So I love self-hosting. I've been doing self-hosting for the better part of the last like 20 years and so. And in the context of this story, I want to remind you that all the domains shown here, they're here for just like aesthetic purposes, because with lo-fi, we're able to use cool graphics of C cassettes and stuff like that. 1890s vibes. So yeah, they're fictional. So jumping into the story. Everybody loves short domains, right? So I registered mine, l0.fi. And what I do with domains that I purchase, I set up my stuff. And with the emails, I always use these like catch-all email, like MTA setup there. So what the catch-all does is that I'm able to set up a unique kind of username, because email addresses are used as usernames everywhere, to each service that I use. So if something gets compromised or, sells my data, I'm just able to block that from MTA and live happily ever after.
And you're a masochist.
Yeah, that's comes with the email hosting, right? Yeah, I'm stupid like that. Anyway, with my setup, these things started suddenly flowing into my email. Emails that are not really supposed to come my way, and they're actually targeted for a bank? Okay, so let's look into here. So L0.fi, right? Well, turns out there's LO.fi that belongs to a bank. So now I'm suddenly every bank employee, every support thing that they may have for their customers that type all these addresses. And that's not really a place where I want to be in. So I do whatever like a responsible person would do. I try to contact the bank security through email, wait for a couple of days for an answer, and nothing. Black hole. Sure, I do kind of get it that there's no real kind of technical good solution for the issue. But yeah, I'm not giving up. So I pick up my phone, call their customer service. Could you please connect me with somebody who's able to help me? Because I think this kind of, it's bad, right? Unfortunately, they're not. Again, no easy technical solution, so we move along. So meanwhile, you probably know what this bad boy is.
Oh, yeah.
Yeah, scanner. It scans stuff. Stuff like contracts, documents, stuff like that. But if you connect that to a network, it can also send stuff. But in case you're doing so, make sure that it's configured correctly. So in one of the bank's subsidiaries, there was this bad boy who was badly configured. And now my email gets filled with people's bank documents as well, contracts and stuff.
Why not? Winning.
Oh, please. Okay, so there's nothing that the bank security can do at the moment, so yeah, we just, like, time passes, summer comes along, and what do you do during the summer?
Have a vacation?
Yeah, go to a hacker camp, right? So in 2017, there was this camp called SHA, and there, in a Finnish village, there were people from NCSC, FI, basically the Finnish CERT people, and I explained the high-level thing of this to them, and they were like, oh shit, I'm going to connect you directly to somebody because they have the hotline. But unfortunately, I don't have my keys. I can't do anything about that with me from here, but let's do it when we get home. So we get home, NCSC, FI, they're awesome. They're like a basic part of the Finnish hacker community as well. They deliver like they always do. They connect me with somebody, a lawyer. That's not the most like a comfortable place to be in as a security researcher / hacker, right? However, the lawyer was awesome. The discussion was civil, and yeah, there's no technical solution. So I ended up, like just giving the domain away. I didn't have anything important at that point. So that's the end of the story, right? Not quite. So a couple of years in the future, I registered a new short domain, ki.fi. Everything nice and dandy, set up my catch-all stuff there.
But that's totally different.
And these start flowing again to the same fucking bank. How? Well, a quick glimpse to the keyboard points out it's a one-off error. Your hand is one off. Now, I already have the contact. I contact the bank and like, okay, it's me again, hi, you never guess what. And they explain the issue. And like this time, unfortunately, I'm not going to give the domain away. It's nice. And there's no really kind of visual similarities. It's not cannot be considered phishing or anything. And the bank people actually did the smartest thing. They gave up email altogether. all the customer communication happens within the bank application. The issue is dealt. And this is actually the end of the story.
But it's actually the beginning of another one. Because in this January, me and Jonah were hanging out at Disobey. And we're good friends. So we're having good times and sharing ideas about loot and stuff we found. And I told her about my catch-all DNS kind of thingamajiggy. And said that it was really tedious, but I found so much cool stuff, so we should really look into it. And after some discussion, we realized that it was a really tedious process. And the only way forward would be probably to scrap it all and then redesign everything and then have something really cool.
Yeah, but it's a shitload of work, right? Like, we're not young guys anymore. Like, do we have all of that in us? Like, it's a lot of things that we have to do, like DNS server, it's like everything. So I'm really doubtful, but should we do it?
Fuck yeah.
Yeah. So, yeah, we're super.
So we built Certainly. and Certainly is a great tool for you. And it listens to everything. It's your friendly butler. The really nice thing is that it also says yes to everything. Super polite. So whatever you send it, it's going to say yes. And it delivers on-the-fly certificates. So if a request comes in, it's going to say, oh, here's a fresh, juicy certificate for you. And what an excellent choice you did, sir. And then pass it on. So the flow here is, this is what, let's get back to the idea where we were in the initial idea with the bit flipping parts of it. So remember this. It flips in the memory of the client. WordPress turns into WordPress. It sends it over to the upstream DNS. The upstream DNS is going to talk to the root server, and then it's going to talk to Certainly. And what Certainly does here is that it's going to respond back with a defined IP address that you set in the config file. It's going to log all the information, so in the future you will know what kind of stuff that was trying to talk to your box, because it's great for recon. And we thought that was a cool idea because most of the previous talks on this subject talked about DNS poisoning. So we thought, oh, cool. We'll just respond back with not just a legit answer for the domain that we have, but also for the matching pair domain.
DNS poisoning.
DNS poisoning, and it's super cool until we realized that shit started to break like real hard. so we have to remove that, and but it's open source, so you can figure out how to do that. And that means that the client is now getting the nice Certainly response coming back, and it knows what to do. So the next step is going to be for it to connect to that server that has and perform the first part of the TLS handshake.
Yeah, so basically this is where the HTTPS part of the whole communication takes over. So what happens there is that obviously client opens a TCP connection, starts the TLS handshake with sending the client hello in. The client hello contains the domain that they're trying to fetch the certificate for. And Certainly goes like a hold up, pauses the whole TLS authentication, the TLS handshake and the TCP session. And while everything is taking a break, Certainly runs in the background, goes to the CA and that, hey, I kind of need this certificate, please give it to me fast, in a bit of a hurry here. And yeah, the CA will provide the challenge for Certainly that they need to kind of use to prove their ownership of the domain. And Certainly is certainly happy to serve and answer to that challenge because obviously it controls, it has the whole like a DNS stack in it.
Yeah, we
so
built our own DNS server.
Yeah, it has all the keys. It can do that. So it provides the challenge token. CA goes like a happy, thanks, all good. Here's your certificate. Now run along. And Certainly says thanks, gets the certificate and provides that to the waiting client that has now been paused on average for 3 seconds. So no real timeouts there. And the client is of course happy because the certificate is valid for the domain that they requested for because the flip happened pre-flight. So they are kind of expecting the flipped certificate as well. And the client is happy to provide Certainly with all the loot, all the nice things that we're discussing here. And Certainly we'll take that graciously, put it into a log file for future analysis purposes, I don't know. but then it does the most gentle thing. It passes the customer along with the 307 temporary redirect, because we don't want to break things here. We're the good guys, right?
Yes, we're the good guys.
And after that, certainly just graciously backs off from the whole process. The client is back at the original server, and everything is nice and dandy.
Because we realized that in any kind of customer relationship, it's very important to treat the client with respect and grace, because then they seems to be a returning customer, which is super sweet.
Customer retention.
Yes, so be nice to those. So here you're thinking like, oh, cool, I want to do this too. How can I get some domains? Well, Luke Young did some really cool research a few years back, presented at DEF CON 23, where he shows that you can do this with a nice ROI, and he has a cool data set and released a Go tool called BF Lookup. We're going to use that as a reference. You can build your own or use this. So what you could do is to use BF Lookup and ask it for WordPress, and what it's going to give you is the options that are already registered for this domain, the flipped ones, and the ones that are available. If
the stars are free.
Stars means that are up for grab, which is super nice. So in this case, for WordPress, we had about 28 domains to buy.
That's quite a lot.
It's not a lot of money in the first part, but I mean, that's an easy investment. But the second time when you need to renew those, it's going to be a little bit steeper. And if you do those for a couple of hundred domains, it's going to be very expensive. So we need to find a way to funnel down. And one way we realized, how can you do this in a way where people don't need to buy all the domains? So I looked into this research here where some really smart people broke down the whole idea if it's a bigger or higher chance that one will flip to a 0. And if we look at the data here, we can see that it's a higher probability if a bit goes from a 1 to 0, and it has to do with something, keeping a charge requires more energy, and then it just easier flips to a 0.
Electricity and magic, right?
Electricity and magic. So we figured that. Okay, so O is the character that has the most ones. Same for, and W is a good one too. And if we look into this, they have something called character siblings, because O can turn into KGMNL and W VSGCP. Those are their neighboring ones that will turn into something when one character happens. There are obviously a lot of more different characters that have these, but some of them flip into Unicode characters, and we're the ones, and we want to have the ones that has the higher probability to turn into something that DNS likes.
Yeah, hey, you people there in the back, are you able to see the last line? Because if you don't, I have some news for you.
Yeah, probably laser surgery. So we're going to go on the other way around. Then we have the ones and the zeros here, right? So A and B are the ones that has most zeros. If we look, and they are on the other part of the spectrum, so these are good too, but there are some minor challenges with these. So let's say that if you have, okay, just look at this bit here. This bit here, if that flips, it always changes, like if it's a lower or higher case. Yeah, that's always the same.
And DNS doesn't care, right?
DNS doesn't care. I mean, that's why if you're looking through your logs, it looks like somebody has been doing this let kind of thing. When you request to, it's normal flipping. And but if you flip this one here, all these 1s to 0 instead, well, this character turns into different ones. Couldn't believe and a backtick. And backticks are cool.
Yeah, we love backticks, but not in the DNS really. Well, there are
DNS doesn't like it, so this is just showcasing that could happen, but it's better to stick with these ones that seems to be very high probable ones. And out of these, we are the most likely then to flip into other characters. And what we realize is that it's actually K that has the higher probabilities. So O likes to turn into K. Then it's G and M and so on. So if you want to do like buy in a couple of domains and you want to have a good ROI on your sneaky shenanigans, then go for something turning out to K. Somebody else obviously did that for WordPress. Smart. But these are the other options that we would be presented with to be able to buy if we wanted to, instead of buying 28 domains, buy these 5 and 4 and you have a good time. Because all it takes is Exactly that single character from 1 to 0 to turn WordPress into WordPress. Cool. But how about top-level domains? If we look into all the TLDs that are out there, there's a bunch of them. And if we run a little bit of a curl to the current data set, and you see, okay, how many of these are there in there? It's 1,447 minus one line, so it's 1,446 TLDs currently.
That's quite a few.
Quite a few. So now when we have internet hacking things, I asked ChatGPT to take all this and compare which are the ones that has a relative flip sibling. And it shows out that it's actually 348 of them that has the potential to turn into something else on the TLD level. And what I'm meaning here is that .io actually flips in .im. So, and .im is the Isle of Man. So you can actually buy a .im domain there. Somebody thought that it was a really good idea to buy metamask.im. I wonder why. I definitely didn't buy it, but I bought a bunch of other cool domains. Mwahaha. You have this also as well. Com flips very easily into BOM. And BOM is a now soon-to-be-released kind of domain where it's Portuguese, and BOM means all things good. And hey, why not? When things are good, why not try to pre-register for Amazon.com? Well, I'm the proud owner of that. We'll see if that goes through or not. Another option would be for you to buy a GLTD or vanity one, but it has a little bit of a other challenge, because the best one that you could get would be KCM, obviously. I mean, that would be a winner, but it comes at a steep price. $185,000 for the application fee.
Yeah, so make sure you have a kind of pretty good justification why you should actually have that top-level domain.
Yeah, you need to prove a lot of stuff.
Doing a bit flip research is probably not one.
No.
And as a bit flip researcher, you probably don't have 185K.
Yeah, and an easy way to understand how this works is like, okay, wait a second. So, Nike, they have all their infrastructure on .Nike. Flips to .Nike, So there's a lot of chances that you get that. And whatever kind of other characters, looking at these major TLDs, you can flip it into something else if you buy that right domain. But it's going to be expensive, and you need to prove it.
Yeah,
so
and also with the existing CC-TLDs, which are the country TLDs, there's a lot of interesting geopolitical
there's
things
so
in there.
many things you can do here. Anyway, we want to be serious and replicate the results as interested for the science of everything. So since we now had, certainly, we thought that, okay, we really like space things, so we're hoping that we could in some way or form prove that it was the space laser kind of mazingis that did this. So using the bit squatting, we bought 25 domains, and that's from cloud SaaS providers, package repos, and other stuff from stuff that you use every day. And we ran those for 4 months and 23 days, hoping for something to happen. And we got way lucky, because in May, planet Earth got hit by the strongest solar storms in 20 years. So it was like awesome, and we're sitting there like, we has infrastructure.
Yeah, we're basically just waiting for that beautiful solar storm to hit us.
He's like, yes. It's like pure Nordic love for everything. It's like, yeah, it's going to be awesome. And we agreed to not look into logs until Monday. So like, yeah, it's going to be so awesome. We looked into it, and like, nothing.
So yeah, you can actually see here, like, it's lower than average.
And we started to go back in time and then compare all these other weather kind of thingies with if we could see any spikes for that period. But it's still nothing. And then this appeared.
Yeah, so I was actually at the airport. We were on our way to Vegas for the Black Hat presentation. And I spotted this new research paper. It was today, it's like, 2 months old. A great research inspecting the correlation between DRAM errors and the cosmic rays.
The thing that we wanted to time.
Yeah,
they are scientists.
It's done by Barcelona Supercomputing Center in collaboration with the European Space Agency and the University of Athens. They have a vast data set with all the different sorts of hardware and stuff like that. And the results? No correlation. The last 15 years of kind of the main theory around that was that it's cosmic rays.
None
But
of that.
no. They, in fact, recommend the previous research to revisit their data and see what's up.
Right, so there's no way that you can blame it on space weather anymore. It actually, you need to take a little bit of ownership because facts remains. During this period, we collected about 62 million DNS requests coming in. Out of those, that turns into 2.8 million signed HTTPS requests, TLS, that we had coming into our box. But we also got about 15,000 emails.
That's a lot of Viagra.
And Nigerian princes. But in fact, there's cool stuff there, because remember this bad boy?
Yeah, this bad boy.
Seems like those tend to do things.
So returning customer as well. So these things, yeah, they scan things. If they're connected to a network, they also send things. And apparently, bit flips happen in them as well. So yeah, we get these emails with scans of people from, yeah, these
From a
enterprise
Minolta computer
scanners.
for someone, and that's a good PII capture.
Yeah.
It has nothing to do with your bank, though.
No, no.
Different domain. So, and this is the juicy stuff, the spicy things. That we also collected about 2,300 OAuth authentication tokens, JW tokens, and all that jamma jazz from multiple Fortune 500 companies, and that we more or less had account takeover. That's a lot of accounts. That's a lot of devices.
Extra spicy.
Extra spicy. And with having this in mind, the recent Snowflake data breach, it kind of puts the whole idea of like, okay, this is probably not as good as, it happens way more than we thought it would do.
For sure.
And it's way more bad than we thought it would be. So I can hear you like, okay, shit.
So what am I supposed to do? Well, obviously, the process starts with like everything else, take responsibility.
Yes.
So figure like just take action, start to do stuff. So the first thing, the most obvious thing is obviously getting these bitflip domains.
Yes, and it means that if you are a company that has an app or something, these are the things that you need to do, not you as hackers. You can do this too, though.
So yeah, you can go like a cheap route, getting the domains that are most likely to flip, or you can do the amazing Amazon thing. They got it all, everything.
Yeah,
that's good. Another thing that you can do, especially as we saw a kind of over-representation of mobile devices in our data, you can do cert pinning. But while implementing cert pinning, make sure that you actually do it right. Because remember, we're talking about pre-flight requests here. So if you have a basically mapping with a certificate and their fingerprint, the flip domain is obviously not in the map. So if you fail open, it's just not going to do anything.
we're going to get it.
Yeah. So yeah, take care when implementing. And the kind of coolest and probably the most ambitious way to fix this would be in the programming language core network libraries, and to have them do the same super nice thing that OpenBSD pledge system does, which is basically during the application initialization, you would tell the network library that these are the domains that we are going to be talking with, and adding an extra step in the whole certificate validation process to make sure that those are the ones, and kill the connection if it's not.
Or you can blame it on DNS and keep on ignoring it and living blissful forever after. I have no problems with that. But I think your customer's going to have a problem with that. And I hear you wondering, like, so why is all this happening? And
Not cosmic rays.
and I mean, so again,
Not cosmic rays.
no, yeah, absolutely.
Yeah.
So why does it happen? To be fully honest and transparent, we have no idea. So that's why this call is this talk is a call for research, because we realize that it's a loads of apps that people built out there that just suddenly just flips in the memory, or something happens pre-flight. We're not even caring about this in traffic negotiating down TLS kind of client discussions. That's another part. But so one theory would be that it could have to do with some kind of row hammer thing, that since it's running in the memory of a computer, it reads the same string over and over and over again, and it flips there because we get so many returning customers. Or that the whole agreement over the year that it said that it rarely happens is due to the fact that it rarely got caught. And there's so many potential ways this can go wrong. I mean, it's everything from CPU to CPU cache, memory channel, network.
Snipe. So we are both really easily nerd sniped. We hope that we were able to, like get your brains going here as well. Like, because now the tool that we wrote, certainly, it is out there. It's open source, FOSS. You're able to get that, so you're able to kind of continue where we left here. Everybody's able to take a look. So what certainly does is that it is a DNS server. Obviously, able to add like multiple domains, have all of that mapping between the flip domains that you registered and the original one where you should be redirected to, and stuff like that. It has like HTTP, HTTPS, IMAP, SMTPS, and stuff like that. But the coolest thing here is obviously that it does in-flight, on-demand TLS certificates. So you kind of don't have to pre-validate everything, and you're able to catch even the very first request coming in.
Yeah, the anomaly. We get the first anomaly. You just get that.
Stuff happens rarely, but there's like the whole like a DNS zone is usually vast, so it's something else, something new many times. Obviously, has injection templates, stuff like that. So because we're in control of the traffic, we can, do some shenanigans there as well. It's there to point the impact, right? We do the logging like a JSON format, so JSON lines format, so it's easy to ingest into your favorite data analysis engine.
Because there is a lot of data. We log everything.
Yeah,
so it's massive amount of data that you can go through, but it's also great because you get a lot of requests that you can look into.
Yeah. It has all of these functionalities to kind of mirror the state of the upstream target, basically doing like a upstream DNS checks before answering these requests. Does the same for HTTP, HTTPS.
If you want to be sneaky. Like
exactly.
if you're doing a red team engagement and you want to sneak around and not leave a lot of certificates, then you say, maybe this is the only domain, or I want these certain ones to, if they're in my scope, then you should allow the request, otherwise it's just going to drop it. Yeah,
and you're able to do like stuff if you want to know when stuff happens. You're able to set up, like these Slack notifications with the whole thing, and it does has a lot of like bells and whistles. Got nerd snap, right? It's fully customizable. It's open source, MIT licensed stuff. So feel free to go and poke and let us know what happened. So the tool called Certainly. It's available here at the GitHub repo happycakefriends/certainly in GitHub.
And sorry, Dr. Love, for stealing your name, but we got stickers. So
that's
I guess
we are authentic, right? Because we got the stickers.
We got stickers. Anyway, use cases for this would be if you're running this. Say that you're a pen tester, bug hunter, and you have a target. You get a couple of domains for your new target doing your pen test or whatever you're doing. You're running this because there's going to be a shitload of DNS requests coming into you that has nothing to do with just going into the full HTTP connection. It could be that the target doesn't allow any outgoing egress, but you will get the internal naming standard. And that's going to get it way easier for you to doing brute forcing when it comes to DNS lookups, and you will have a bigger idea what actually happens to that organization.
Yeah, and especially like larger enterprises, they typically have these like dual horizon DNS setups where the internal network actually sees something more than the external network and so on and so forth. But it all gets disclosed here.
Exactly, and since it collects all the head, post, get, all the jamma, you'll get all the data that's in there. It's going to be cool. So it's very easy to use for parameter farming, because if you couldn't guess the parameter, somebody might just have supplied it for you.
Yeah.
Cool. So, and you also get shitload of scanner boys. So if you want to be able to know whoever hits your stuff right now, then spin up a couple of domains, because every time a new certificate gets hired, all the boys come running. And that's perfect if you want to either be able to, well, maybe use their payloads because they're giving all their exploits away. Or you can, in this case, just identify if there's any risk that you need to deal with.
So yeah, all in all, we need more eyes on the issue. We need more research on this. We need more people with like other vantage points than we do. Obviously, we're there at the end of the pipeline, just like looking whatever comes our way. But we would really love to have people that have the visibility over the hardware and different layers. As we showed, it goes through the whole thing, right? But most importantly, I think it's we need to act on these things. Like, we have things that we can do today, things that we can do right now to protect against this. They are not perfect. We don't know the root cause, but we know something at least that we can do. The most important thing, however, is to recalibrate our trust anchors. So everything kind of things go wrong because we think that the computers do always the right thing. They don't make mistakes. They do the exact thing that they are programmed to do. But I don't know. Turns out computers are humans after all. So thank you. My name is Johoy, and
I'm Stoke Frederick. Thank you for coming to our talk. Any questions? And that stuff is going to be elsewhere. What? Have fun.
Yeah, sure, you can catch them and ask questions afterwards. We're going to have a quick break. But seriously, why do you think it happens, though?
Why it happens?
You can tell us.
I can tell you that it has nothing to do with space radiation.
Yeah.
And we're not really sure. We just see an exceptional amount of data that wasn't supposed to be there. And we didn't think that it would be happening. But you can see, like, even in Cooks in their talk, they were running certainly, and they got hits to their Maven. So, I mean, there's so many ways to use it. I think we're just very good at just being very nice, and that's why, we capture the shit.
It's clearly 5G then.
Extra spicy.
Extra spicy.
For sure.
All right, we're going to have a 30-minute break, go out, have coffee, and be back here at 3:30, yeah?
Hello? 3-minute warning. Next talk starts in 3 minutes. Okay, please take your seats. We're about to start the last block of talks for this year's SecT. Good.
Hello, everyone. Welcome to our talk. It's going to be about our journey at Einride and how we build our vulnerability management program. So let's jump straight into it. My name is Anton. Before joining Einride, I worked at Spotify, KPMG, and played a bit of CTFs.
Hi, I'm Samuel. Before joining Einride, I also worked at Spotify. I've also worked at Cloud Query and several other companies, both in the US and here in Europe. But what is Einride? Einride is a global company with offices in Sweden and the US, and with operations in the US, the UAE, and a lot of Europe. We are an end-to-end carbon-freeing company that focuses on electrification for transport. So we do this by operating electric fleet of vehicles. We also have several charging stations around the world, including the largest in LA for heavy freight transport. We also work deeply with our industry partners, both operationally and in security, and we have a freight platform that makes it easy for people around the world to ship their products in a decarbonized fashion. Our end goal for this is to switch to the autonomous transport mechanisms that will allow safer operations as well as cheaper and better working environments for the drivers.
So a little bit more for you to understand, because we are here to learn about technical stuff. Our stack mostly consists of Golang applications, and everything is deployed into containers through various continuous deployment and continuous integration pipelines. So DevOps all the way. We mostly run everything in the Cloud Run. It's a containerized product by Google Cloud. But we also, as you could guess, run a lot of stuff on our vehicles. It's most of the time containerized stuff that runs on in containers on some sort of Einride OS, we call it, in Kubernetes or something like this. So what we're going to talk about today is what is vulnerability management at Einride, what kind of parts it consists of, how it evolved over the time, what kind of vulnerability metrics do we use, and what we think about those. What kind of challenges do we see and still not solve it, and we come up with some takeaways.
So vulnerability management at Einride. We are currently supporting around 22 engineering teams. So these are teams that work both on our cloud solutions as well as on vehicle software. We're aggregating data across many vulnerability sources. So as we mentioned before, we have several different operating environments, and we have different sources to help us find about our security issues for each one of those. And our current standing today is we have around 60,000 vulnerabilities in our management today. So we have many different diversity of execution environments. So we have your normal environments that you might have at a normal company, so laptops and workstations. We also have a lot of cloud infrastructure, so we run our web services in the cloud. And we have office networks and servers that make up our day-to-day operations. We also have vehicles like freight trucks, autonomous trucks, and vehicle networks that we need to worry about. And newly, we have charging stations that have IoT charging devices, as well as networks that we need to manage remotely. So an overview of how our management system works is that we have a data source for each of our vulnerability findings. So for the cloud, we're using something called Orca Security, which is a cloud security and container security system, which reports vulnerabilities on the assets we have there. We also have DependentBot, which gives us information about our dependencies in code, and SimGrep, which gives us information about our application security in the code. And for our devices, we use something called CrowdStrike Falcon, which you guys are all probably familiar with, whether you've used it or you've heard about it in the news. So we have many different sources for many different platforms, but we want to manage them all in one single fashion. So I think all of these services, they offer a single pane of glass for developers. So if you're operating solely in the cloud, you can use Orca Security to manage your vulnerabilities for the cloud. But that doesn't help you if you have different vehicles or different environments like vehicles, which it wouldn't be helpful for you to have developers log into a cloud security system and then log into a different vehicle security system to manage their vulnerabilities. So what we've created here is a data management plane for our vulnerabilities. We're using BigQuery for our data fabric or our security data lake, but you could use whatever you'd like. So we're not here to talk about specific products, but more about how we approach managing our vulnerabilities in general. So once we aggregate all of our findings from these sources, we create dashboards and create notifications for different audiences. So one thing that you might encounter is, like, while these services offer a single pane of glass for dealing with one type of vulnerability, they're also focused on engineering. But we need to provide data-driven ability to make decisions to different audiences, such as leadership, managers, and the engineers. So here's an overview of one of our dashboards. This gives us a quick view at all of our security issues, whether it's in the cloud, code finding, or some other type of finding. And for each different type of finding, we have a different dashboard, which allows you to dive deeper into your findings. So here is an example of our cloud misconfigurations dashboard, which allows you to dive deeply into you or your team's security issues, and you can sort them by whether they're in different GCP projects or AWS accounts or anywhere. So we also track your vulnerabilities over time, and then you get a nice dashboard here where you can dive deeper into the issues. So another thing is about looking at a dashboard and seeing what is the overall overview of security, but we also want people to take action on their issues and deal with that in a timely manner. So we started off by having a Slack notification, which would tell everyone how many issues they have for each type of issue, as well as how many they have over SLA. So if you look closely and use your imagination, you can see how these categories in our Slack message correlate with the different sources and types of vulnerabilities that you may have. So now that we have a bunch of different vulnerabilities aggregated into one source, we also know that everyone has a different view about what is a vulnerability. So some vulnerabilities may not apply to us. We might have mitigating factors in place or something that makes a vulnerability irrelevant. We also might not always agree about what is the severity of a vulnerability. I know it's a very common topic in security to discuss what is the severity of a vulnerability, and in which cases would it be lower or higher. So we've created a tool here which allows us to manage this data in a code-oriented way. So we have a tool which allows us to exclude vulnerabilities or adjust the severity depending on different aspects. So there are 3 key concepts to our vulnerability management platform that we need to implement in order to have a unified tool that allows us to use all of our vulnerabilities in one place. So key is having resources. So in Google, you might have like a database or something like a storage bucket inside of a project, inside of an organization in the cloud. So what we've done is we've organized all of our resources into a tree, and on that tree we have different findings as well. So all of our findings have a kind of tree-like path which relates a security issue to a resource. And on top of that, we have owners for all of our resources. And the owners are teams or individuals which own the resource. So then here we can have a end-to-end solution that allows us to route every finding to the owner of a resource. This requires us to have clear ownership for all of our resources. So in some places like clouds, it's easy to do this through tags and labels, but this is something you need to think about for every single vulnerability source. But because we have this tree-like infrastructure, which allows us to specify different rules on different parts of the resource tree, we're able to create inheritance and overrides that allow us to exclude some vulnerabilities for specific resources, but include them everywhere else deeper in the tree. So once we've created our vulnerability exceptions with this tool, everything is created as a YAML file, which then we can manage through our standard Git operations. So just like any other policy as code, we have a YAML file with all the details we need, and then we have GitHub, which allows us to have auditability and an approval process. So here we have like an exemption request. Engineering teams can make this themselves, or we can make it for them. And then we have a specific approval process depending on the severity of each vulnerability. Once we create the pull request, we have similar CI tooling, which uses this tree to tell us exactly what this vulnerability exemption will apply to. So if you're approving an exemption request, you can see what is the actual effect of that request today. Additionally, these exemptions are tied to a time. So we can define an exemption today, and maybe this could be an example where we have a product which we're sunsetting. So while this finding is a proper finding with a real vulnerability and a real risk, the service that we're defining it on will be sunset in like a week. So then we can set an exemption process which takes this week into account, and if the service is not sunset within that week, all of the notifications will come back to your dashboards and your notifications. So this is where we started, but as we all know, feedback is the breakfast of champions. So we have a process where we continuously learn and evolve from our engineers' feedback. So we have a quarterly process where everyone will submit feedback to us, and then we will act on that feedback. So one example of improvements we've made is that engineers are overwhelmed with the type and amount of vulnerabilities that we have. So previously we had dashboards and notifications which would show you all the different categories and sources for your vulnerabilities. Now, if you're an engineering team who has normal production work that they need to do, it's hard for them to know, is today a day that we should fix a cloud misconfiguration, Or is today a day that we'll fix a container finding? So what they requested us is to have a simpler system for their most important vulnerabilities that they can fix today. So we took their advice and we built a new system where we have focused recommendations. So here you can see in our new Slack system, we give them the 3 most important things that they can fix today. We also show them the severity of the vulnerability and the source of their vulnerability, and we help them define what should be fixed today. Of course, this also shows up in the dashboards. So we have a dashboard for every team with their vulnerability findings, but they can also look at and see how these findings change over time. So these are the findings for the September to the 12th, but they could go back in time and see what else could have been fixed before. So it might be that a new vulnerability comes out today, we have log4j v3, and that's important, but it might be a big effort, so they might want to look at other things to fix as well. The Slack posts are a great start, but it would be more fun to fix things if top-performing teams would be highlighted in the company. So we thought this was a great idea as well, and we created the Security Champions Leaderboard. So this picks 3 different metrics: the most closed findings, the most closed severity points, depending on the severity of the findings that were fixed, and the average age reduction in their finding age. So some vulnerabilities are been around for like a whole year. If it's a severe vulnerability that's been around for a year, it's more important for us to focus on that than maybe a new vulnerability that's fresh off the boat. So nice job, team. We also have a Security Champions Slack message to correlate with our dashboards. So we track the same metrics here, and we offer a link to look at the dashboards or the leaderboards whenever we send a message. So as you can see, we like to lead by example. We're here number 2. We'll be number 1 soon, I feel it. And the next is Security Fika.
Yeah, before proceeding, I'm really curious to ask you, who is an audience likes Fika? Please raise your hand. A lot.
Everyone likes Fika here. Are we in Sweden?
What's your my next question is, what's your favorite bully? Yes, absolutely. It's like, the more bullies, the better, right? So what Security Fika is, it's a meeting we hold with, we have with some engineering teams. We select somehow, we will talk about it in a moment, but we bring some Fika, we discuss the learnings from what team made, what kind of feedback we could provide as a team, what kind of feedback they have. So we change some advices, our views on the problems. So we exchange our opinions, and of course, with Fika, so that makes everyone happier. And we do it with a team who is doing great, like I would say top performers. But we also select teams who we think might have to look for opportunities for improvements in the various areas. It's not necessarily a bad team. It's just a team who needs some help. And we enjoy meeting with them. Let's jump into the metrics then. So far, we're running this program for a bit longer than a year, and according to our data, around 88,000 vulnerabilities was fixed. You might think, oh, it's great. It's like we fixed thousands of issues. But on the other hand, as of today, we have 59,000 open. And that's led us to the thought that something is not really cool with it. So we dive deeper into the data and figured out that around 70% of our vulnerabilities owned by vendors. So vendors running their software in our environment. And we have not that much leverage over them because we cannot fix their vulnerabilities. It's their responsibility. And we have a number of those issues, of those vendors. But on the other hand, we use it quite successfully as a leverage during negotiations with those vendors when we extended our contracts with them. So we were not only a blocker as a security team, but also an enabler, and we earned some money. That was great. VNIB. So the idea of number of fixed vulnerabilities, calculating it, doesn't allow you to actually figure out, okay, there is a team who fixes it or who owns 100 vulnerabilities and a team who have to fix 20 vulnerabilities. Who we need to help first? Are they same? Are they different? But the teams are different, and one team might own only one service, which is old legacy. That's why they struggle with a lot of things with that service. But another team run all pretty new software, everything is latest infrastructure. There could not be any issues with it. So it's really hard to compare teams by number of vulnerabilities. And it's really hard to see who is doing better or worse. So that's why we don't really, the dashboards what you saw before, they are for teams themselves. So they could see, oh, I have to prioritize this and that. That's what's my team's posture. And also as you could see it on this graph, I found it pretty interesting. Quite soon after we rolled out our vulnerability management program, we reached a sort of plateau of number of vulnerabilities our organization could fix in a day. So it's something to think for us as well. According to this data, it's like around 150 vulnerabilities a day. It's quite a lot. So what we use instead inside of our security engineering team to select how teams are, to figure out how teams are doing, how a whole organization is doing, we focus on a bit more free two-dimensional metrics. Specifically on this graph is one of examples. So vertically, we see a number of vulnerabilities owned, was fixed by a team during the last 90 days, let's say. And horizontally, it's time it took them to fix. So because we own all the data, we could actually calculate when a vulnerability first showed up, when it was fixed, what was its priority, who owned it, what's the team name, what's the resource, etc. And the bubble size is average severity of vulnerability. You could notice that some bubbles are really small, because their vulnerabilities are low severity. And if it's bigger, it's probably something worse, like high or even critical. But what we did, we just looked for outliers, and if it's something when it's a story, and we have to talk to that team and figure out what's their process. And we just learn a lot about their business. Another great thing was not only measure vulnerabilities what was fixed, but also those what are currently exist, and we measure the average age of vulnerability, and the same approach as on the previous graph. So by doing that, we see not only how team performs in terms of how fast they fix vulnerabilities, that was the previous slide, but here we see their current state. So we could help them prioritize things and maybe address something earlier than later. With all that, we have still a few open challenges. It's hard to talk to vendor, sometimes because they have own business, and they own a lot of our vulnerabilities. We, of course, implemented different countermeasures to it. So like defense in depth and building fences around and borders around all the things that look sketchy helps here, but still doesn't feel right when 70% of your issues is somewhere else and you cannot do anything about it. Another issue that we faced is ownership attribution. So while we claim that we have a robust way to attribute certain vulnerability to certain team, it's a startup, and they do reorganizations here and there, left and right. They rename teams, they change ownership of services, and it's kind of struggle. So we have to be on top of all those updates and quickly improve and fix all our records. And our struggle is if you calculate just a number of vulnerabilities which are open right now, and each team will fix one vulnerability a day, it will take 1 year of them to fix everything. It's just impossible even to imagine how company will be able to do it. So for us, when as a security team, it's an open question: what kind of other sort of programs we should run to enable those teams fix those issues faster? Maybe we could do something in our infrastructure in general, so we could fix it for them. So that's what we're looking for quite often, and that's what our work is around as well. The next one is that we rely on third-party tools to scan for vulnerabilities. Samuel mentioned what we run. We have Orca, SameGrab, Dependabot, etc. The issue we have with those is that they have their own understanding of a life cycle of vulnerability, when it's open, when it's closed. For example, if you delete some resource in Google Cloud, that's the cloud that we're using, some vulnerability scanners will still have this vulnerability open for a certain period of time and repeatedly report it back to us while it's still technically not exist anymore. And I mean, we have a valid concerns as a vendor to do so, but it's not really in line with what we are doing. That's just one of the examples. Also, we have a different understanding of what kind of severity to assign to vulnerability. So there might be some misunderstandings between vendor, us as security team, and feature teams that's going to fix that vulnerability. One final struggle is it's actually hard to do dashboarding and reporting because, you know, it's a human experience and we are not UX folks. We are security engineers. We like terminals, but people like graphs and tables, I don't know what. So it's always a new learning every day. So what we've just went through, we went through how we set up our vulnerability management program, what kind of critical parts in it. We have exception systems. We have a communication channel set up. Everything is automatic. We have a gamification set for it. It all runs automatically. It's no manual work included, besides fixing bugs in it, obviously, and debugging it when people complain. But otherwise, it's our security engineering team quite small, so we have to automate everything. We discussed how our program evolved over the time, what lessons were learned, what metrics we used before and what we are using now, and what's ongoing challenges. So our critical components of something, if I will repeat building the same thing in a different place or again, it's first you have to have a robust asset inventory system. So you know what kind of resources you have, where are they, what's their status, are they alive? So if there is some sort of shadow IT or some server under the desk of engineer, you better know about it, otherwise it's a nightmare to track all of this. That should be resolved problem. In our crucial component is automated attribution of security findings to specific teams. So we have to know who is responsible for what. And it's not like one person is responsible for the whole GCP cloud. That doesn't work. That person should be, it's a team, because you remember the bus factor, it should be a team who is able to fix something and do something about it. Next one, there should be ways to automatically communicate with teams. They have to have ways to get data without constantly talking to you. They have to have ways to provide feedback to you so you don't run around and asking them, oh, please go fix this. And they will complain, no, we think it's false positive and we decide not to fix it. Everything should be automated. That's why we should have a robust exception system that is quite flexible for your setup. Obviously, everything will not work if engineering teams have no time doing that, and business, as a stakeholder of all this, doesn't support it. So this should be working as a whole organization, and you should have a buying from all levels, from bottom to the top. And I think last but not least, crucial component is your risk appetite. The risk appetite of your vulnerability management program should be in line with the business you're running. So imagine a startup like we and a military defense contractor. I guess security requirements are way different. And while we could accept having thousands of vulnerability open, and we still have defense and dev and countermeasures here and there, so it's not like welcome everyone, but still it's quite significantly different situation if we would run a submarine factory plant, I don't know. So we should adjust our approaches. And that's it. Samuel?
Yeah, I think if any of you guys are dealing with these problems yourself or have any questions, please feel free to reach out to us on LinkedIn. And thank you for coming to our talk.
Okay, thank you so much. We're going to do one of our famous flying changes, so we're going to hope that all of the tech is working. Thank you, Anton and Samuel. And our next speaker will take us on a travel through a greedy sheet developer, I think. So thank you and welcome, David L.
Yep, go ahead. Check, it works. Perfect. Last talk of the conference, how exciting. So today I want to talk to you about something that's near and dear to my heart, which is malware and cheats. We're going to start with a little bit of a brief history about cheats, how they were developed over the time, and how cheat developers evolved, and including how game developers evolved, how to protect against those cheats. And then we're going to talk about a specific case where a cheat developer got caught red-handed, a very interesting case. So let's get started. So a little bit about myself. My name is David. I'm a malware researcher for CyberArk, and I've been doing malware for about 8 years or so. At the same time, I've been a game developer as a hobby, and I helped both manage and create a little indie game studio. So right now, I'm not doing that too much because I'm into security and malware, but that's that. And an interesting fact about me is I'm a foodie, and about 3 weeks ago, I graduated from culinary school, so I'm officially a trained chef. Thank you. So let's get started. Just a random question. How many of you here have ever cheated in a game? Good to see that pretty much everyone. So I'm in good company. So I think it's not going to be too surprising to you guys that the oldest and the simplest way of cheating is built-in cheats. So they're usually left behind on purpose by developers, like Easter eggs or little consoles for tools to actually check out and test the game itself. In multiplayer, they're usually guarded by permissions, so that's not very interesting. But I do have one story about that. As a kid, I was playing a lot of Grand Theft Auto with friends, and usually just a lot of teens huddle up in front of one computer, And every time someone was not looking, we usually just wrote this code extreme fast and exploded all the cars around us, including the car the player was sitting at. It was really funny, really fun. Also led to a lot of physical altercations and some fighting. So that's that. But if we take a look at things that are actually break terms of service, so we're going to start with the simplest and easiest thing, which is local file modification. Things like configurations, save files, maps, textures, obviously highly effective in single-player games, but the question that I posed is it possible to do this in multiplayer? So specifically in this case, World of Warcraft in 2006 wanted to actually answer this. So in 2006, I don't know how many of you had a chance to play World of Warcraft back then, but a massive new update was released with a new raid called AQ40. It takes about 40 players to finish, and between 1.5 to 3.5 hours, but great loot. So a lot of time. And you need to understand, this is prior to Discord, so communication then, if you remember, it was really difficult. Here's the map. And essentially, you start from the top at point A, and then you had to go through the massive tunnel system. And if you died at any sort of point, you had to go back and start it all over again. Obviously, very tedious, takes a lot of time. So a clan called Overrated wanted to ask the question of, is it possible to skip from point A directly to point B? The thing they noticed is the dark brown area just below A is actually the roof of area B. So luckily for us, they actually filmed this back in 2006 and gave us a very nice video. Hopefully a lot of you people feeling a little bit of nostalgia of what they did. So for people who don't remember or have never played the game, this doesn't look like the game doesn't look like this. They essentially, for all 40 clients, just remove the walls and floors, and the purple blob there is actually the boss. So somehow they bypassed all the security checks and all the things like that, and just spawned the end boss in about 15 minutes, had great loot, got banned, and that was that. So what's the solution to protect against this? So obviously, verification. Verify that you have all the files, verify that you have all the textures correctly loaded, verify the game is executable, so things like Steam actually do that automatically sometimes. And also validate player actions, so World of Warcraft changed their game from client-centric to server-centric, and added emphasis on player verification, which was very nice. But this is fine and simple and pretty easy. Let's talk about something much more interesting. So external memory verification is obviously really hard to detect. Again, highly effective in single player where we don't have any synchronization, but it could also work in multiplayer. And this is only talking about the variables because I wanted to give a massive spotlight to pretty much the most popular cheating tool out there, which is Cheat Engine. So very quick recap for people who haven't had a chance to use this. Basically, it is a tool in its core functionality to find a correlation between a value that we see on screen with a value in the game memory. So we do that by scanning the memory for a specific value, we change it, we scan it again against the list we got initially, and like that. I know it's kind of hard to understand over the top, through words, so instead I developed a little demo for us, just so I can showcase this. And there you go, it works. So let's imagine this little guy here wants to go through the wall where it says coins are required and wants to get the treasure, which in this case is free drink little coupons we had. So obviously, we don't have enough coins no matter what we do. Using Cheat Engine, it's rather simple to actually bypass this. So if we open up, and hopefully you'll see, we can choose the window, which is my project because I forgot to rename. And we scan for the initial amount of coins, which is 100. We get about 3,500 addresses, and that's fine. And then we scan it again and find the address that has changed to 101, which, there you go, we have 2 addresses. Anyone wants to give me a number to change this to? 9,000. Over 9,000, so 9,001. And the wall is down, and we can fall. Sorry about that. But yeah, essentially this works. Very simple, very easy. A lot of games are still vulnerable to this. Any game that is single player is usually vulnerable to this. The simplest fix actually is just adding like a random number to the end while you're storing this. Usually just bypasses all those tricks. But it's nice. And luckily for us, the demagogues were nice to us and gave us the no need to use the video. So that's cool, but what about some actual cheats that are actually impressive and scary? Things like aimbots, ESPs, which are the little boxes that you can see enemy players through walls, or even wall hacks. All of those require additional logic to the game. And additional logic means hooking and understanding the memory space. Every game engine is a bit different. Specifically, I'm going to talk about Unity because this is the engine I am familiar with the most, and also the simplest to showcase on because it's usually in C#. And level 4, the memory itself, Unity uses a game engine system where it has game objects. It runs all the game objects. Every game object has a position, a size, and a location, which is a transform. It has a couple of components that are built in, like colliders, which is the physical shape, or the render itself, which is the texture that we can see. And we can also have some things called like a movement controller, which is essentially a script. Every script has to have initialize, which gets called when initializing the game object, and an update, which gets run every time we have a tick. So if you ever had a lag where it's not related to the network and it's related to your computer being just overloaded, the tick rates are going to get slow, and the update function is going to be called in time, and that's what happens basically. And of course, we have a lot of subscriptable events and on-clicks. So I want to make a aimbot. So the most basic logic for aiming and shooting is when we have a mouse click, we gotta get the gun direction and again going to spawn a bullet and shoot in that direction. Of course, as cheaters, we want to always aim for the head. And it sounds simple, right? We're gonna just pass the get direction, override it, and now we have a aimbot. So in actuality, it's not that simple. Unity is written in mono.NET, usually is converted to using a tool they built in-house called Intermediate Language to C++, which is a whole mess in itself because it's not actually C++, it's just a mishmash. But luckily for us, there are awesome tools out there. One of them is called Melon Loader, which is a universal mode creator for Unity. And essentially, instead of creating, hooking, injecting, all those crazy stuff, we can just use a custom mod, or how they call it, melons, and just profit. So, luckily for that, I did another demo because I wanted to showcase this live instead of a video. And ignore the fact that it's called very frustrating balloon shooter because we're gonna shoot apples. But if you can see, this didn't show up when we initially launched the previous game, and this is the Melon Loader. This allows us to very easily sideload any mod or any cheat we want. Also, there's something called Unity Explorer, which allows us to see all the objects and change things from inside of the game itself. But if we close this, I already can tell you that I already loaded a aimbot here, the mod itself, which is very simple. It goes through all the apples and finds the first one in the list and sets the aim point to be that. And it's enabled by just pressing a single keyboard. And now our aim is locked. And I don't know if any of you had the chance to play any FPS games on a trackpad. It's hell. So instead, we're going to use this. And as you can see, we can easily just automatically aim. And that's that. So obviously, very powerful. Again, demo-codes worked. How about detecting this? So first thing first, Melon Loader is essentially a side loader. So you can see a lot of folder structure and directory and stuff like that. Pretty easy to detect. When it comes to more advanced cheats, they're usually injecting directly to the memory. So here comes into play things like kernel level anti-cheats, because essentially it's memory access. And when we have a specific code injected to a game, it requires an injector. It requires some access, and this is all done in user space because games are obviously user space. I don't think anyone here is sane enough to create a game in kernel space. Thus, every access to the memory itself is going to be done through a driver. And anti-cheats sit there, monitor every access, and decide based on a lot of heuristics if it's a valid access or if it's something malicious or cheating, to be exact. Sorry, I'm way too used to malware. And in this case, you're going to block. But the problem here is anti-cheat solutions are not perfect. First of all, they're heavily obfuscated, meaning it's really, really easy to find bugs in them, and it's really hard to develop those. So there are vulnerabilities like one that was in Genshin Impact, where it allowed local privilege escalation. Or when they are not that complicated and don't have exploits in them, it's kind of easy to bypass them. So there's a lot of secrecy in that field of the world. So if you want to find any new vulnerabilities that are extremely widespread, go for anti-cheats. And trust me, there's like millions of computers out there with every single one of them. So that's kind of cool. But the big question is, are we cheat-proof yet? And spoiler, no. So the last level of cheats is something called DMA, direct memory access. The general premise here is if we don't have a cheat running on our computer, we can bypass the anti-cheat that's running and checking the game itself. And essentially, it's unblockable memory access. It requires us to use a card called DMA card, how original. And it uses a port, usually either USB or Thunderbolt for the more advanced ones, to communicate and allow us to both read and write to the memory. Now, this setup starts to be very, very expensive because every part here has a very high cost. In this example, I'm showcasing a DMA cheat where we have an overlay showcasing all the enemies. So first of all, we need the actual computer we game on. We need a DMA card. We need a second computer. And we need something called a video combiner or HDMI fuser, to be exact. And the costs rack up pretty quickly because a single DMA card costs between $300 and $700 for the good one, at least. And then you need a $40 plus firmware to be stealthy because it's really hard, really easy for anti-cheat solutions to find like signed firmware and use that to detect you. Then, if you want video, a HDMI fuser is needed, which also costs quite a lot and is prone to be just combust flames spontaneously. If you want something to do with aimbotting, you need to do something called a KM box, which is a virtual mouse and a USB controller. All in all, the bare minimum is about $1,000. Makes it extremely costly and extremely hard to use. Thus, not a lot of anti-cheat solutions actually try to detect this because the entry cost is so high. But nonetheless, when it comes to big competitions and things like esports with millions of dollars on the line, that's one of the things they use. And that's probably one of the reasons why one of the bigger events always have the event in person, where they can verify the computer is clean, there's no cards, there's nothing hidden, no matter what the players themselves bring out to stage. So you probably saw that we're missing a level, and that was on purpose. The level is bought-in trainers, which is essentially the whole cheat I found. So this is going to be a little story about a cheat developer that had a lot of new clients where we caught him doing some very naughty stuff. I'm giving you a little bit of time if you want to scan the QR code. Has any of you had a chance to play or heard about Escape from Tarkov? Awesome. So for those who haven't had a chance, Escape from Tarkov is a very, very military-style shooter where you have a lot of survival aspects, a lot of sound aspects, like literally emulating combat environments. It has about 40 million copies sold, somehow still in beta, nobody knows. And the cheat itself is meant for that. It's called Evolved Aim, and it's essentially a very simple automation tool where you can go to sleep, and it's going to do a couple of stuff for you. The first one is going to trade automatically in the auction house, get you some money, which is kind of fun. Then you wake up, you have some money to spend, all good. And then it's going to train some repetitive skills like stamina. So if you ever had a chance to play the game and you saw just random players running naked on the beach itself, that's that. It's very weird. It's kind of low risk because it uses only optical and image recognition and uses the Python functions to send keyboard and mouse commands, pretty easy. And it has an estimated clientele of 1,500. The crazy part about this is it costs about $35 a month. So that sounds good,
And it has, because of this cost, a couple of extra features. So feature number one is we're going to have a little PDF instruction manual. Pretty nice, pretty cool. We're going to have a virtual machine, a way to detect virtual machines, a way to detect memes, and a couple of ways to take screenshots. Yeah, I'm really interested in the way they actually detect memes, because I don't know about you guys, but I get a ton of memes through Slack pretty much every day. So let's try to reverse engineer the meme detector, because I'm interested. This malware is in Python 3.11, which I'll show a little bit later down the line, poses some challenges. But we'll start with the fact that the meme detector is under the anti-virtual machine class, which is already kind of weird. And okay, there you go. And if we try to look at the function itself, it's going to do some decompiling and complete, which essentially means we don't have support for this. Python 3.11 is not supported by any decompiler right now. And in reality, we just got accepted to Black Hat's Arsenal Europe with a tool that uses a LLM to convert bytecode back to Python source code. So that's going to be pretty cool. It's going to be called bytecode LLM. But before that tool and before we did all of that work, essentially the only way we could analyze this is by looking at the bytecode itself, which looks like this. Extremely unreadable. It has like 1,000 lines just for one function. But I will summarize this for you and show you the strings. So if you ever had a chance to work with malware, I think you already know what it is. But our memes are, in reality, infrastructure. So it supports a lot of browsers and steals passwords, cookies, credentials, all those, credit card information. They also steal stuff from Discord. So if you ever paid for Discord Nitro, I'm sorry to say, but those guys, they save your credit card information on the hard disk. And interesting enough, they go after MetaMask for every single one of those browsers. They just collect all the MetaMask information and send it back to yourselves. On top of that, it also has a command and control system, which has a lot of commands, pretty cool. It has some grab, which gives them the files, remove to delete. They just sit too much in front of the computer, so they decided to add a kill command to the game itself. So that's that. The question is, where are the memes? So everything is going to be collected and then zipped up into a zip folder, and it's going to get uploaded to Mega. Mega is a very nice file hosting service, but it requires us an email and password, which are essentially stored hard-coded. So if anyone wants to look at this, it's kind of interesting. And I was asking myself, okay, where is Mega located in the world? It's New Zealand. So that's that. If anyone wants memes, New Zealand has all of them. And now, who actually made those memes? It was very interesting to me to see that while I was researching all this malware, they had two names pop up constantly over and over. Always two trusted devices. The first one was going to be called Mythical, and the second one is CJ. And it kept popping up every time, and it was very interesting to see, but I had no clue who those guys are. Until I showed up to their Discord, where they support the tool, and they showed themselves. So, yeah, cat people. But who cares, right? It's just one cheat, it's just a game. Again, 40 million copies might sound much, but in the gaming industry, it's not that big. But the problem is, it's the player base age. This game is meant for more adult people. People who are above 20, who like military stuff, a lot of combat situations. And that, with the added fact of hybrid workplaces and bring your device workplaces, just poses a lot of risk. So imagine just an employee playing on his computer and relaxing, doing whatever he wants, and then a cheat developer collects all of his information and then logs into your computer and your network itself, and you're compromised. And this is only just one example. The industry of gaming is worth over $184 billion. And just in 2019, which again is very outdated, it lost about 29,000 $20 billion due to cheating. So if most of the cheats and most of the cheats that are free look like that, we can assume that a lot of companies can get compromised through this, and I know for a fact that a couple of companies at least got exposed by this attack and got some exposure because of this. So, in conclusion, everyone who cheats, of course, cheats and can get affected, but people who don't cheat can get affected by this. This usually goes through the way of price. So the price of the game is usually hiked up because either companies need to provide for a security solution or to have a full-on team of moderators and developers and all that. And of course, again, the danger to the organizations, even though people are playing at home and relaxing, they still pose a problem. And kernel level anti-cheat are awesome. They really do detect pretty much everything. So for example, Vanguard from Riot Games is really, really awesome and very strong. Also gets loaded first in order and stuff like that. But the problem is they can get a lot of exploits in them. So a single exploit in anything like that, if you imagine a remote code execution with the amount of games, with the amount of users, just the amount of damage that could be done is massive. And again, never trust cat people. So these two blogs were published a couple of months ago, and it got some media traction. So it got some coverage in Italy, one of the biggest news articles for gaming. Also a couple of things in France, Israel, and one of my favorite things is Reddit, where we had a lot of debates of should this article even be published, because we basically exposed the cheat developer and those who cheat are safer. Here goes that. And yeah. Oh, and my favorite one is a YouTuber from Escape from Tarkov community that literally just read word for word what I wrote and did a 10-minute video giving his points on every single thing I did. So that was pretty ASMR-ish, listening to a whole article again read to you. And that's that. Thank you. Any questions? No?
Mike. Okay, guys, that's basically it for this year's SecT. And we really want to thank all of you for coming. We want to thank all our speakers for submitting and presenting. And we do want you to fill out in the speaker feedback form, which has been on this QR code that should be live. And I just want a big round of applause, if we can do that, for all the organizers this year.
Yeah, so we hope you submit something for next year. And
yeah, come back next year and we'll see. We'll try to make it bigger, better. And yeah, we're really looking forward. And please submit. And again, if you'd like to help out, just drop us an email. We are looking for more help with both developing our backend system if you're a developer. We're also looking for more people to help us out in the CFP process. So drop an email to info@sect.org and tell us a bit about yourself, what you would like to do, and how you could help the community. It would be very much appreciated.
Yep.
So thank you all for coming.
Thank you.
We don't know.